sonic anemometers, standalone sonics. They are kind of the standard in the fleet now. You know, these are the types of sensors that are out there. And we're going to go into one of the biggest problems, or not problems, one of the biggest challenges of working with sonic anemometers here in a second. Let's see, not many people still using the old mechanicals, the propeller vanes. I know they're on a few vessels as backups, and I think a lot of vessels still have ones that were probably put on when the ship was built. Because they are kind of, when the ship comes out of shipyard, that's what they put on them, or at least used to. But yeah, there's a lot of maintenance challenges and headaches with the mechanicals. Most people are still using EPLI radiometers, and this again is another challenge in the fleet. You know, EPLIs are very hard to maintain, and they're getting to be more and more of a challenge. Not only are EPLIs getting to be a challenge to maintain, but I don't know, how many of you are any of you running the RMRCO red interface box to interface EPLIs together? This was a company, RMRCO, that's no longer in business. And there's a lot of these translator boxes that would take the inputs from the different radiometers and give you a very nice, you know, proprietary serial string out. And it's very hard to find anybody that can maintain those either. And then if you have to interface your EPLIs directly with your acquisition system, there's a whole bunch of challenges in doing that. So I guess the question then was, you know, do you have a plan to move away from EPLI sensors? And it looks like most people do. I'll have some slides on radiometers. We're going to talk a little bit about what some of the options are for radiometers going forward. I also want to discuss some of the challenges with interfacing them as well. And then in terms of rainfall, most ships, I'm actually surprised, but most actually do have a rain sensor on board. This is great. We want to have rain measurements and precipitation type measurements from ships. It's very important for atmospheric fluxes. Precipitation is a big part of that air-sea interaction work. But they are tricky sensors on a ship. There's a lot of challenges working with them on a ship. And so we'll discuss a little bit more the different types of sensors that exist. All right, back here. So starting off with sonic anemometers. This is going to be one of those parts where, you know, learn from you as well. I want to learn how you're dealing with this challenge. And this is an opportunity to share, you know, your techniques and methods. Because the goal of when you're dealing with any anemometer, and sonic anemometers, they all have a north mark on them. You know, they have a mark that says, you know, which way is north if you hadn't to be putting it on a land station. Well, on a ship, the way we want to orient those is we want to orient the north mark so that it's pointing in a direction parallel to the center line and facing forward on the vessel. Now you'll note this stuff's in italics here. We actually have changed this wording in our documentation because originally what we said was orient the north mark towards the bow. And then we started realizing that some people were getting confused by that. And the best way to look at that is if you look at this diagram, this is an example, you know, where you have, the idea is you have your anemometer out here, you know, off, it's not on the center line of the vessel, but the idea is to orient that north mark straight forward, parallel to the center line of the ship. Well, if you actually orient it toward the bow, you're going to turn that anemometer 20 degrees. And we were like, if people are literally reading what we wrote, we gave them the wrong information. So we've changed the documentation to really make it clear that this is what we're looking for. So now my question for you all is, how do you do it? Go for it.
So where we place our med sensors, it's a surveyed location. And when they put a survey monument, those monuments have an orientation. We can ask them to orient that monument, and then you've got a very accurate, you know, fore and aft reference.
That's cool. Yeah, I didn't even know that was possible. That's good to know. So that could be something to make sure other folks are aware. They have to have survey work being done for their.
Yeah, ask them to place a monument and ask them to make sure it's got a,
Yeah,
FORAT reference on it.
yeah, okay. Any other thoughts? Other folks having to deal with this? So the one question I had, and we were actually gonna test this out, you all probably know Katie Watkins Brand, I work with her a lot, of course, she can't be here because she's a government worker. But she was actually gonna try this out, because we were talking about this one time, and I was like, can you actually take a handheld compass? And if you're in port, you have this gyro, the orientation of the bow, which way the bow is pointing from the gyro. Can you take a handheld compass up to where you're doing this and use that to give you a good reference for which way it's pointing? But then I kind of was remembering back in the days like Boy Scouts, you have these handheld compasses sitting on top of a giant mass of metal, do they actually work? So this is why I'm asking you all. I don't know, if you've ever tried to do this. So. I mean, how do you do it for the script ships? Do you just kind of eyeball it?
Yeah, because we have ours on the end of sticks sticking straight out, so we can orientate as much as we want, but then it's going out. And so there might be some wiggle on the pole.
Mhm.
So we're hoping that we're still pointing straight forward, but we could have moved a degree or two when we bolted it down. So it's kind of hard.
Inclination
Mhm.
wheel, you could calibrate it against the ship's compass.
Mhm.
So if you say, I'm showing 175, but the ship's compass showing 180, you could
Yeah.
get an adjustment and then take it up to your survey location.
Yeah, so you're accounting for the magnetic deviation.
Yeah.
That you get, on the ship itself, yeah. Yeah, these are all good ideas, and that's, we've got folks online taking notes. I'm trying to capture all this information. Another thought we had, and thinking about this example, where we have it sticking out here on a cross arm on a mast. Is there another thing you could potentially do? That would be easier if you're up there on the mast? What if you take this anemometer and you orient it so that you can orient it with the north mark going along the mast, along that cross arm? Then you can correct for that in your acquisition system. You actually do the adjustments to and you have to do that correction to both the relative winds, before it goes into the calculation of the true wind. But you could actually do that offset, this way. And that makes it easier when you're up there installing it. You don't actually have to orient it. Another example would be, that'd be a challenge is, and your suggestion obviously is the easiest one with the survey of reference. But what if you actually had to mount an anemometer at the back of the ship? Say you have a helo deck back there and they have to have an anemometer for flight operations. How do you go about orienting that one toward the bow? You probably can't even see the bow from where you put it. So again, thinking about what you can reference it to locally, that you can then look at like the ship's, plans or diagrams or whatever, and get good angles measured off of that to the bow or along that center line, would be another way to look at it. Other thoughts, questions on that one? All right, looking to see how I'm doing for time here. So on to radiometers. So again, shortwave and long wave, the downwelling radiation is generally what we're trying to collect on most ships. It's the most common measurements that are used for, again, air-sea interaction research, satellite, people that are doing satellite validation, radiometric satellites and the like. But yeah, so EPLEs are getting hard to maintain. They're getting harder to find even. And so there are some options to move forward on ships. And so most of the information that I'm relaying in terms of the options for these comes from this best practice document. This is work that Laura Rigamaki led a best practice group. It is available at this URL. It's actually published in Frontiers in Marine Science. It's also on the Ocean Best Practices system. But they actually, this was a big effort. There's like, 30 authors on here, and there's a combination of scientists and technical people in here. But the main recommendation is the first thing what you're looking for is you're ideally looking for a Class A rated pyranometer for the shortwave radiation. And in this document, there's actually a table of all the companies that make Class A radiometers. So you can actually go and look at them. There's Kip and Zonin, there's I think Huskaflux, there's a couple other companies that actually make these. There's a lot of standards for shortwave radiometers because the shortwave radiometer market is driven by solar industry, the solar energy industry. So there's actually a worldwide standards for these instruments. So that's why this whole idea of Class A actually exists. So that one's pretty easy to decide which one you're looking for. I never pronounced this one right. The pyrometers, which are the long wave radiometers, have no present standard. There's just been no community of real agreement, even among the radiation community, as to standards for those instruments. But again, in this document, there are some recommended long wave radiometers. In the fleet, not just here in the US, but also internationally, there's a lot of move toward Kip and Zonin. Kip and Zonin makes some very, very high quality shortwave, long wave radiometers, and they have been deployed on some of the vessels in the fleet. Oh, going back here. Oh, yeah. So, yeah, I don't have another slide on this. I just have some questions to ask. So, one of the things that we found with the Kip and Zonins is they're not particularly easy to interface into your system. And so one of the questions that I wanted to ask is, we've seen operators struggling with, their people go out and buy them Kip and Zonins and they hand them to them and they're like, go ahead and connect these into your data system and get the data flowing. And it doesn't seem to be that simple. So I wanted to ask the folks here that are using Kip and Zonins that actually have successfully interfaced them, how are you doing it? What's the approach you're taking?
Yeah, we currently have, because we use Met on our Met system, we have a Python script for Modbus. It's sending out straight to the Kip and Zonins and saying, hey, give me the information. And we're having Kip and Zonin send that information back to a port on our Pepper hoops. And that is what's then broadcasting it for unicasting it to the Met system, Open RVTEC, whatever else, wherever we're collecting it at. And it works fairly well. The one problem we've had is, I think you guys want like to a certain decimal point.
Yeah.
And in the Modbus, because that's protocol we're using, settings in KZ, it can like when we reset it, we drop back down like a setting automatically because for whatever reason, Kip and Zonin set up Modbus to do it at a smaller.
Yeah, they'd be like whole units as opposed to 10 or something.
So in Modbus, it's like default is like a 10, but we want to add 100. But then the default for other modes of communication are at 100. It's weird.
Okay. So you basically had to develop some custom software to be able to handle this what's coming from the sensor. Yeah. So, I know Sekuliak also has these. Did you also have to develop custom software to be able to?
I'm not sure about that. I'd have to check you.
Okay, all right. I know when I was talking, some of the folks that weren't able to come, I was talking with James Cason at OSU. They're also going to be putting these things onto the RCRVs. They also mentioned that they had to develop custom scripts to be able to do this. James also mentioned that you can order, data loggers from Kip and Zonin that will handle the data coming out of them. But kind of my question was, because this is not my area of expertise, can you have like a standalone data logger for the Kip and Zonins and still interface that into the rest of your system? Or is that more trouble than developing a custom Python script to work with them? Any thoughts on doing that? It may not be something that we have any experience with. I just wanted to make sure you were aware that that was an option that I'd heard about, So I think one of the things that I'm curious about in the session right before this had to do with the wiki, the RVTEC wiki, is would you all be willing to share your code for interfacing these Kip and Zonins? Because I think this will benefit the community, not just the codes, but just the procedures you use to actually interface a Kip and Zonin with your acquisition system. I think it'll be really beneficial if we could get some, basically SOP procedures for these out on the wiki, so that other people, when they buy these, other techs can look at that and they don't have to, figure it out from scratch.
We can talk about it.
Okay.
Each management approval, all the obviously, but if we get the approval, we can.
And you can check with Gabe on that, maybe.
Yeah, I'm looking right now.
And I know that Katie for NOAA has developed, she had an SOP document that she's put together for Kip and Zonins. So it'd be good if we could get some people together that are working with these and maybe work on, maybe flesh out that document a little bit more. Because I know the NOAA fleet is going all to these Kip and Zonins and they're having no end of problems with their techs, even with an SOP, understanding what they have to do. So I think this would be really useful. I'm gonna talk completely outside my area of expertise here, but one of the things Katie asked me was whether or not you all were using Modbus versus RS-485 in turn. And I assume that's a communication protocol, right? And it sounds like Modbus is what you're using. I don't know what the challenges are of one versus the other. So.
Well, one of the things we ran into, at least on some of our ships, is we converted most of our sensors like on a mass to the same Modbus. It's from the Atom module that was collecting from the other sensors. They all go to the same JBox.
Yeah.
And it's just easier for the data to run as everything on Modbus. Back down on that one line that feeds to everything else.
Yeah.
So because we switched the Modbus for KC, we had to switch the other things to Modbus as well.
Okay, yeah. Yeah, it doesn't sound, I know there's not a lot of people in the room, but it doesn't sound like anybody's tried using RS-485 yet with these, at least the people sitting here. So, okay. Any other questions on radiometers while we're here in general? The one thing I would mention, and again, it's in this best practice recommendation, I think I might have put this someplace, but it's not on the slide. There is a strong interest in the air-sea interaction community to also be able to get a measurement of diffuse shortwave radiation. And there now is and it's documented in here, it's called an SPN1. I think it's Delta something, Delta T or something is a company that makes it. It's a small, radiometer that measures both direct shortwave and diffuse shortwave. And it's something that the radiation community would like to see more on chips. Now, of course, we fully realize what kind of budget climate we're in right now. Trying to move on to adding a whole nother sensor is probably not going to happen. But, just kind of keep in the back of your brain that there's some science driving for getting this diffuse measurement if we can, down the road. My understanding is these are not super costly sensors. The Kip and Zonins are way more expensive than this SPN1 is my understanding. Okay. Rainfall. Measuring rainfall from a ship is a challenge, no matter how you slice it. Just because rain is such a point measurement, the ship is, a structure with a lot of weird airflow going over it. But the types of rain sensors that exist are the classic old siphon gauges. This is an R.M. Young. There's a one made years ago from the Haas gauge. These are volumetric gauges. They actually capture the rain itself. The ones that are becoming, again, more common are the acoustic rain sensors. This is the one that's on the WXT. Again, they seem to be performing well. We've been looking at the data. We've seen where we're seeing and recording rain when rain happens. There are some, open questions about these sensors because I've not seen a lot of validation studies with them. If any of you have, I'd love to, get reference because I just have not seen many. But the acoustic rain sensor, what it does is it's listening to the sound of the rainfall hitting it. That's the sound of the raindrop or the hailstone or whatever hitting it, and they can translate that into a rain rate. Works really well for rain, works good for hail. We have no idea what it does for snowfall because snow is going to be a much different sound when it hits that. And so there are some real questions on those mixed precipitation types, what kind of values you get. Of course, they're also prone to other good things. Birds love to sit on them. We have birds tap dancing on the top of your rain gauge. You get some really interesting rain data. So that we see that does happen. The Ravel is notorious for it, and when out in the tropics. So some of the ships we see it more often than not. The other type of rain gauge, and this is actually way more than a rain gauge. These are the optical sensors. They basically are operating by, sending a beam of light, and they're doing, attenuation calculations from, what's falling through that beam. But these are really the cutting edge for doing precipitation measurements. Not only do they give you the rain rate and the total accumulation, they can tell you what kind of precipitation it is. They are also disdrometers. They'll actually tell you if it's a sleet, snow, what kind of precipitation it is. And they actually can provide the weather codes. These are the WMO, weather codes for whether or not it's sleeting or snowing or foggy or whatever. So that's a new thing with these. And then they also can give you a visibility measurement, an actual, in kilometers, visibility measurement. So these are, really, in a lot of ways, the way we would like to see the fleet go. These are really, they get a lot more out of them. And the question is, why use these versus the volumetric gauges that were very common in the fleet still? This is work done by a colleague of mine in at NOAA Physical Science Lab. She is an expert in rainfall measurements and air-sea interaction, done a lot of work on ships and direct flux measurements from ships. And they did a comparison of optical rain gauges and the volumetric siphon gauge from R.M. Young. And the thing to note is the purple curve is the rainfall from a rain event from the optical gauge. And you can see how high frequency that curve is. And the first thing to notice like at the beginning, I hope you can see this from the back of the room, there's about there's a period of time where it's raining that the R.M. Young gauge doesn't capture at all. It doesn't actually start capturing the rain event until the rain event has been going on for a while. The other thing is the peak rainfall, the optical rain gauge is much better at high rain rates. The R.M. Young gauge tends to undercatch on these. So this is just some of the statistics. One of the things is that the R.M. Young can only really resolve. It's kind of binary. It's like it resolves either 0 or 5 millimeters an hour. It can't get anything in between. It's just the nature of the ability of the sensor. In terms of accumulation in this event, the difference was 11 millimeters from the optical gauge and 5 from the R.M. Young. So you're getting half the rain capture using one of the volumetric gauges. a lot of things that the RM Youngs are prone to, the evaporation, sloshing, the data actually, the water moves around, so you get some anomalous signals, from them. The way these work, you're probably familiar with, they basically have an electrical capacitance measurement in them, so that's how it's actually making them, determines how much water's in that gauge. One of the things we just found out, this came from our colleagues in New Zealand. We had some really weird rain gauge data from their RM Young. We were trying to figure out, it turns out that in their case, one of the things that had happened is soot and grit was actually getting into the gauge, and that soot and grit actually had a metallic component to it. It changed the capacitance measurements. And so they were getting anomalous rain data. So the solution was, of course, getting the whole thing cleaned, can be done. But, again, on a ship where you have stack exhaust and all these things, that's gonna be a pretty common problem, I think. And it may be sort of a reason why we've seen some anomalous readings from other ships. We just have never confirmed it. So just something to be aware of if you have one of these volumetric gauges still. They really do need to be maintained fairly frequently. Yeah.
I was just gonna add, so I mean, we have the optical ring gauge on Skuliak, and I don't know if you recall, we saw a lot of interference with our S-band radar.
Yeah. Causing
Anomalous precipitation events.
Yeah.
But ever since we replaced to a brand new S-band, that appears to have been resolved.
Yeah, and I know that's actually one of the, I don't think it's on my slides, it is one of the still kind of open questions about the opticals, is they're sensitive to EMI. So where they are on the ship is gonna matter, what type of radars is probably gonna matter. That's what we found with Sikuliak. Was it a different bandwidth, the new radar? Is that what happened? I mean, the new S band at a slightly different frequency, was that, or is it
I
just?
don't remember the exact details, but probably.
Yeah, so, but yeah, so, there's still some work to be done with these. But the one thing that I wanted to bring up for the community was, and for this community in general, as I noted, we don't have much validation work for the WXTs, these acoustic ring sensors. And I think it would be really interesting if we as a community could do some kind of intercomparison study. Get some ships that have, volumetric gauges, WXTs on board, if possible, one that could, actually have all three, systems on board. And it may not even be essential that we do it on a ship. Even if, we can do it at, a shoreside facility. If you have all the instruments, we can set them up someplace. I think it'd be really interesting to do some intercomparison studies between these different grain sensors. Because I don't think they exist for the WXT. At least I've not been able to find anything. And the WXTs do have the advantage of being really easy and simple to work with. They're not high cost. These optical sensors are really nice, but they probably run what? $20,000-$30,000. They're not cheap. So, especially the new ones. Any other questions on the ring? Yeah.
For anybody who is running those WXT sensors, it'd be really handy if your group could provide like a recommended set of settings. Because in the configuration software form, there is you could get crazy with the customization. Yeah. So it'd be nice if you're like, this is the recommended state.
Yeah, we can certainly,
sensor.
That's a good point. We certainly could look into that. And I think, again, Katie at NOAA has an SOP for, they're doing WXTs on the NOAA fleet as one of their systems. I'll have to talk to her and maybe, I think we could come up with a good standard for them. Yeah. Anything else? See where we are in time. I guess we got another 15 minutes. So the last thing I wanted to bring up is kind of where we're going. Where's the SAMOS project going after, now into our 21st year? These are some of the things that we're going to be working on in the next year. We really need to modernize we are dealing with a code base that is ancient. And we are still running, Fortran 77 for some of our standard processing software. Our NetCDF files, we do use NetCDF, we have for years, but they use an older standard. It's actually a CORDS compliant NetCDF format. We need to transition our NetCDF format and the way we handle flags in our NetCDF files to be a CF standard. So we're gonna have to redesign our NetCDF formats. We really want to start using more controlled vocabularies, just like we ask you all to do in terms of like data acquisition systems. We need to get those controlled vocabulary into our data files as well. So we're using CF standard variable names, and when we know there's an instrument that's this instrument, you can map those to controlled vocabularies. We also are going to be expanding parameters as we move into using some of these newer sensors we were talking about. We actually be able to handle visibility, weather codes, and different aspects of some of these advanced precipitation sensors. So we definitely want to start adding those to our system. We definitely need to do a complete end-to-end rewrite of our quality control system. Again, like I said, it's a mix of about 5 different languages. And we want to be able to redo that, open source it, make it actually a community resource. Updating a lot of the QC procedures, updating climatologies, etc. Our visual quality control tool, which our data analysts use, is a 22-year-old IDL application. It's been around forever. It's rock solid. It works, but it's got all kinds of bugs and problems. So we would like to actually build a web-based quality control system. So we can do this as, a series of web tools, and then ideally they'd be useful for other people as well. We've been thinking about, and this is kind of Amanda's area, we've been thinking about looking into the AI ML approaches. There's, I think it came up in a meeting, one of the sessions, this idea of anomaly detection. In theory, we should be able to use these techniques to detect anomalies in the data. Whether or not those anomalies are instrument problems or actual weather events is really the challenge. You can find the event, but then you have to really train the system to understand what's a real thing and what's an instrument problem. And then the last thing I was going to mention is we really want to modernize our data services. You can get to our website. We've got a thread server. You can download the files. The data are all accessible, but we would like to move to more modern data services where all the data are available in systems that you can hit with an API to slice, dice, however you want to. These are some examples. We actually just finished a 3-year project to take all our shipboard data and calculate air-sea fluxes from them. And the air-sea flux products are now actually available through ERDAP, which is a data service that NOAA developed. And what we want to do is get all the SAMOS data into an ERDAP service. So it'll be, back-ended in a way that you can just go in and select a region on the globe, get all the data in whatever of the 40 formats that ERDAP will put out. The other thing we've developed is a user, this is the user interface. This is actually for being able to look at the data and actually make plots, comparison plots, overlay it over satellite data. This is an example of over the data over the tracks overlaying on SST, satellite SST. This system was actually developed by NASA with the software as an open source package from NASA that we've integrated. And so, the examples are just showing comparisons from different cruises of air-sea fluxes. But we would like to advance our user interface. And one of the things we'd really like to know from you all is, are there like display tools you'd like to be able to see, or data subsetting and slicing and dicing tools that would even be beneficial to you all? Anything that we could, develop in this avenue would be nice to know. Yeah. All right. So that's kind of where we're going. Hopefully, we'll be able to continue for another 20 years. But yeah, and tomorrow at the plenary, we'll be having a little celebration of this program that we've been able to keep going for this long. And in no small part to you all. I mean, we couldn't do it without the techs. This is how SAMOS runs. And I wanted to emphasize the fact that, these kind of meetings and group gatherings we have, we're learning from you as much as you're learning from us. We are the data processors and, I mean, I did instrumentation 30 years ago when I was, working in Antarctica, but I haven't worked with instrumentation hands-on much recently. You are the ones that are out there installing them and working with them. So we learn from you, every day. It's great. So we still have about another 5 minutes. I did want to just open the floor for any other questions for SAMOS. Are there things that I didn't cover, things you just burning questions in the mind? I can certainly give a shot.
What's the status of the ingesting directly from Coriolis for you guys?
Ingesting as in,
We said normally, email to SAMOS, blah, 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 but we've been talking about having.
doing a pull versus a push?
Yeah, what's the status of that?
Very good question. We can do that. We actually do a poll from Australia right now. Our Australian and our New Zealand vessels, we actually pull their data. We're pulling it from a thread server, a shoreside thread server. All we would need to know is where is it living? So there's actually, and I can't quite remember how Coriolis works in terms of their, I know there's a ship side and then there's a shore side, but as long as we knew where the SAMOS formatted files land on the shore side server, we just have to set up a pipe to it and we could start pulling instead of pushing. Something we could experiment with. Yeah. Yeah, we should just add that to our to-do list as we're working with the Sikuliak and the Coriolis working. But yeah, certainly can be done.
And I imagine whatever work we do in that regard, Sikuliak would be applicable to the RCRVs and any other ships that.
Well, that's the hope is, we had originally planned with Coriolis that we were going to prototype all the SAMOS integration work with the Tani. Of course, it's been delayed, so we're doing this all with the Sikuliak. So you are going to be our guinea pigs. But yeah, no, I'm hoping all the work that we do, will then be applicable to any ship that uses Coriolis down the road. Yeah. And I know there were some people I was talking to yesterday, some of the other operators that are looking at Coriolis, and they were like, what are we gonna have to do for SAMOS? And I pretty much told them, once we figure out all the bugs with the Sikuliak, it'll be automatic. It's part of Coriolis. So it should be pretty seamless. Anything else?
When you talked earlier, you said you would like to have R2R event logs for the centers when they get changed and when you do all that, as far as I understand, once we have Coriolis, that is in Coriolis also, so you don't need to duplicate that effort, right?
Yeah, this is, and Becca might want to chime in here as well. Again, the R2R event log was designed as a science event log. My understanding is Coriolis has both a science event log and a sensor log. And I think for what we would be wanting to do with Coriolis equipped ships is being able to access the sensor log information. I think what the group that Becca and I are trying to work with, this whole idea of this event log harvesting, is it'd be nice to be able to try to standardize all the terminology and stuff, so that if you're using the Coriolis sensor log or a ship doesn't have Coriolis and using the R2R event log, we can just still go look for the same maintenance, or malfunction, and get it from any of them.
The other downside, from what I understand of the Coriolis sensor log, is it's very unique to each ship, so it's not standardized between them. And that includes like actions and locations, and like these are the things that we're trying to standardize. And like get communication and be able to talk to each other. Because what Sean has to do is he has to understand exactly what that sensor is, what the exact problem is. And right now their QC flags don't match with action vocabularies.
Yeah.
So then we're trying to, yeah, I mean, that's one of the things we talked about, like once Our target lumber has an API, we should be able to push and pull, so like Royal and any other logs out there, like the C log, and RVTEC, so the idea is to be able to communicate to each other, but get to that, having to talk the same language, so that's kind of been the hard part.
Yeah, so yeah, we are talking with Victorialist developers and, you know, about some of that stuff as well. Yep. We're gonna get there. Any other questions? I think we're at the end of time.
Great,
All right.
thanks, everybody.
Appreciate it. Yeah.
Okay.
So right now, so we have to do the, but even where you always see what.
Yeah, for a lot of notes.
I just.
I will be taking the ship to Vegas. It's not going back. So.
Some of them are captured.
That's fine.
And then all of the.
I didn't have anything.
No, I was trying to. Get on the road, right? But all of the rules are saying, when they sort this out. I'll see you when. Exactly. I could probably do the same. I don't see those. The amount of interaction with this.
Oh, yeah.
It's not a good thing. You got about every response for each of the questions. And I think that's.
Yeah, and yeah, I mean, that.
Yeah, we can even take a look at the individual level to see.
Well, yeah. Just think, one of the things we could do.
I think there's like food out there too, so.
One of the things we may want to do is send our board out, you know, so. The RVTEC, those are people. Yeah.
Doing the same thing with our sensor.
All right.
Yeah.
Hi, everybody. Thank you. Thank you for coming in. I don't do this kind of thing ever. I think this is my first time ever like presenting anything other than like a plenary. So and I have a splitting headache right now, so I'm trying to like muster energy and figure out how to move slides. Oh, no. Oh, there we go. All right.
Got a little bit.
So a little bit about me. I don't really consider myself a programmer, though I think some people might, you know, I'm on the UNOLS page as programmer, but that's not really how I think of myself. And because I kind of started doing this as I got into college, doing hardware design, you know, there's like an assumption that when you're designing hardware that I do understand the software, and I did. So I had to teach myself, and I first kind of got into it doing JavaScript and XSLT. Does anyone know what that is?
No.
It's a super niche thing to like make technical manuals, basically. Or like scientific documents, but it's not important. So it's, you know, 20 years ago, so I've been doing it a while. But I really kind of cut my teeth on doing it with office automation, because you know, I worked in the Navy at the time. The Navy started getting really serious about cybersecurity, and they took away the ability to use any software other than Microsoft Office. So I was writing some stuff that had no business being written in Office VB scripts, yeah, like array processing algorithms for submarine, weird stuff like that. But nowadays, I started with C++, C# is like my favorite, and then, just recently, last year, I started teaching myself Python, because that's obviously the elephant in the room right now, so. And I taught myself PowerPoint just to do this. Last night. I finished it this morning. All right. So why did I do this? Because it's something that I've never seen at RVTEC before. I thought it'd be fun. And just observing things that I've seen over the years where people start doing it and then get discouraged. It's like, well, you could have approached it from a different way. And, because I want to see everyone succeed and learn to do this, because it is an incredibly useful skill for everyone to learn. And, you don't need a degree. You don't need to be smart. You don't need to, you need a keyboard, and that's really about it. And a lot of patience really would be the only personality trait, but that's a learned skill, right? And also, Tara had open spaces and she was asking for people. So, if you've ever tried to get started, you probably just start with a Google search, right? And you're immediately just overwhelmed with just words, right? I recently got into Amy Poehler's new podcast, and she uses this thing like terms that keep you out of the room. She references it like in regards to Hollywood, but it applies here too, right? It's kind of scary when you're having things thrown at you. You don't know what they mean. You don't know how to start the information, and it immediately discourages you from going any further. And also, we all read Amazon reviews, and you read all the 5 stars and the 1 stars, and you can't get a good. It's hard, it's hard not to be influenced by things like this, but I try not to prescribe to this sort of thing, like a valid argument versus like an invalid argument. But Python sucks, like that's not productive, and that doesn't help anybody. So overview reviews, make good decisions, and we're going to talk about that later. How you can make good decisions. We're not really going to do any code, so you don't need to know any of that to sit here and get something out of it. So we're going to talk about what is code, what is a programming language, how to make choices to get going, and just some advice that I can give you. It's only like a little snippet of advice. My headache's going. All right, so what is code? So the advent of how computers work started before even electricity was a thing, right? People, mathematicians, scientists started figuring out that you can arrange switches in such a way that you could do mathematical operations with them, right? And then you start with like the simplest circuit that can do. Does anyone know what this is? One person. So this is an add, right? So just a couple of transistors, and you could use that to add, A plus B equals either 1 or 2, and so you start grouping stuff like that together, and then you end up with a big scary microprocessor, right? Something that, and this is a really old one. It's probably only got 2,000 transistors on it, and new ones have billions. But how does this, just logic gates and transistors, how does it become Mario Kart? That's a big, and the answer is it is a lot, right? But I don't think you don't need to know all that in order to kind of grasp how you get from A to B, or from A to like F. So these like big scary microprocessors with billions of transistors, they have a very discrete function, right? They only do 3 things really. So you have registers, which are just little holding cubbies for little pieces of information that you're using at the moment, right? You have a control unit, and that's probably the most complicated part, but that's the part that's like saying, what do I do now? What am I going to do next? And what am I doing in the past? It gets little instructions and flips little gates to do the next thing. And the arithmetic logic unit, which does addition, subtraction, and logical operations. which don't really need to know about now, but you notice that, just like a fun aside, there's no multiplication and division there, right? Because computers at their fundamental building block level, you cannot multiply or divide, right? And you can look in it's a fun read, interesting. And then the clock, the heartbeat, that makes it all go, right? It's like, that's the river turning the water wheel to run the mill. So the next part is the RAM, right? And one of the most common things I hear, not from technical people generally, is the confusion between RAM and storage, right? RAM is directly tied to the processor. They have little heart hands because they're best friends, right? One can't work without the other. So, and in your head, just think of RAM as like an Excel spreadsheet. You have rows and columns to store little pieces of information. And anything your computer is currently using at the time is in the RAM. It's not on your hard drive, right? That's something you need to kind of stick in your head. So this kind of helps you understand how you get to Mario Kart, right? So your computer is not just your CPU and RAM and all that stuff. It's a bunch of computers. There's probably 200 computers in this laptop, right? And they're all doing their own thing and working together. And they do that, nowadays, it wasn't always like this, but through the RAM, right? Through a process called memory mapped IO. So, you have like memory segmentation is a very important thing that you need to kind of remember, that each device in the computer has its own little section of memory. If you go out, like a graphics card maps to a section of memory, and that's how you draw pixels on the screen. You have a section of your memory dedicated to the storage controller, which reads and writes from your hard drive, and some random PCI device down there, whatever it is, an Ethernet card or a USB card, something like that. And on top of that, you have the operating system, which maps out its own little sections of RAM. So what is code, right? That's what we're getting to. So these chip designers, smart people they are, they build into the chip little operations, and it's quite literally circuits that need to be energized to do certain things, whether you're going to add, subtract, multiply, divide. And that is directly tied to the architecture of the CPU. These are the two dominant CPU architectures out there, x86 and ARM, right? And so the chip designers, those aren't codes that you're going to write and do something with. Those are codes that are built into the hardware, right? And just to do very simple things, add, subtract, move this thing from here to here, right? You guys following? Good?
Yeah.
All right. It's not always boring, but it's fundamental knowledge, right? So those little opcodes built into something called the machine code, and the machine code is the actual instructions that the CPU is able to execute, right? And what that is a little opcode, and then the additional information that needs to do something with that. You're going to add. Well, what are you going to add? You're going to add this plus this, or you're going to, copy whatever is stored in this RAM location into the CPU, so we could do something with it later. So now, I've given you enough information that you could sort of understand where we were in the earliest computers, right? Where you had punch cards and, people would actually have to sit there and, punch out little holes for each machine code to do a little simple operation. I know at URI, maybe at your institution, you could still find file cabinets full of these things, like writing an application to do probably some like ultra simple thing with a stack of cards like this, and you had people that would just feed. You could be like one of these people, wear a suit to work and feed cards and So then. That's not very practical, right? People don't understand money. People like it, you know, even if you're like a computer engineer, hardcore person, you don't think that way, right? So, like the first real like programming language was called assembly, right? And there are simple instructions that are, you know, somewhat human readable. You know, it's still ugly, it's still difficult to follow, but a human being can actually start to write to do practical things. Yeah, fall asleep, right?
No.
Okay. So. This application would work on Unix, on a Linux Unix machine, just to write hello RVTEC to the console, right? But, you know, it's still not very friendly. And that's why nobody really writes in assembly anymore. It's not something you hear about often, right? So in order to use that, because your machine can't, your machine doesn't understand assembly, it understands machine code. So you have to run it through something called an assembler, which is just another program that will take your assembly, translate it to machine code, which can then be sent and executed. And this is going to be a little more important later, like this in between step. And then, yeah, I made this up. This isn't a real like dumb great thing, but it's just turning your assembly into codes that your machine can execute. So I figured we could do a little walkthrough. If any, I don't know if we have anyone on Zoom, but probably just me like pointing at things. So you have a CPU, a couple of three little, you remember what these are called? What was that? Alice?
No.
Oh, all right. Three little registers, a little section of RAM, right? So first thing we did was we moved the value A4 to register X. We just moved the value of column B1 into register Y. Now we're going to add X and Y, put it in Z. You know, you could think of this as like, remember we talked about memory mapped IO, right? You could think of this as maybe we're adjusting the color of one of those pixels in Mario's hat or something, you know, it's and then we just move that value back into the RAM, and look at that, we just made a pixel, right? So that's still not very practical, right? That still take a long time to do something useful, right? To follow those steps, right? So thankfully, we have operating systems. And so I put little heart eye emojis because you should appreciate them for what they are. You know, you could probably get frustrated with them, right? But they do several key things, right? They manage the memory for you. You don't have to think about it, right? Some people in here probably programmed some before, right? When's the last time you like worried about the memory? Yeah.
That much.
Process management, making sure that you know, on your computer, there's probably 100 things running simultaneously, or they appear to run simultaneously. Device management, getting things from the hard drive, putting things on the hard drive. So, you know, you don't have to worry about that. File management, and most of all, security. And you know, security in that you're not going to crash your machine by interfering with something else, and security, quite literally, where you're preventing unauthorized access to things that, you know, your credit card number that you just typed into your web form. So you now kind of know that this simple pseudocode example, right? Open a file, how many steps that your computer has to go through just to do that. You know, you're going to the operating system and you say, what is this file? Do I have permission to open this file? Go to the storage controller and get that file and bring it back into memory. And, you know, it's a lot. So this one little command is probably thousands and thousands of those machine codes that I saw, right? And this is when you can actually start to get some work done. But just have an appreciation for what is going on in the background. It's a lot of steps. Is this going okay? You guys?
Yes.
All right. All right. So at this time, I'm going to recommend a book to you. I think every technician should read this book at some point. It's free. It's available as an ebook, but it kind of gives you in an entertaining way. It's not a textbook, but it gives you like a fundamental understanding of where we are up to the point.
Bedtime reading, right?
No, it's pretty interesting, and that's not even like a nerd point, like it's in an entertaining way. It kind of starts with shining a flashlight at your friend to signal like something into, embedded. So, thank goodness for high level programming, right? These are the ones that you probably heard of going on the Reddit screen, like at some point in your life, you probably heard some of these words mentioned, right? So, what do they do for you? It's easily even readable, debatable depending on your experience level, but hides away all the hardware access. You don't have to worry about all the stuff I just showed. It's important to know, but you can forget about it, right? And do practical things, get work done without killing yourself. One little command to do 1,000 machine codes. So this is just something that I like to look at every year is the Stack Overflow. Are you familiar with that website? It's a website for programmers to ask questions and get help questions. Every year they put out a survey and they have the most popular everything, most popular web browser, most popular everything, but the programming languages is interesting. Sometimes you see things climbing up the leaderboard, it's kind of how you stay alert and relative to, you probably, if you've been paying attention at RVTEC, you obviously know that like Python is by far the dominant programming language right now, but it will not always be. It hasn't always been, it's a very recent thing. But I'd say if you're gonna go for it, it doesn't hurt to stay in that top quartile, because you're gonna have a lot of support. You're gonna have a lot of examples to follow.
Can I ask the question of what makes one better than the other? Like, or other than popularity, I mean, why do one be more popular? Is there a reason?
I think we'll sort of get into that, but some of these are purpose built for one specific task. Some of them aren't even programming languages. HTML is like, you're probably all familiar with HTML. It's like how you make a web page, but there's no commands being executed by HTML. So you gotta read this with and it's also just based on interaction on one website. This isn't a definitive list. So I kind of already went into this, but your assembly code, how many steps it takes just to write on your console to say hello RVTEC versus a high level programming language where it's one little command, right? And it's not scary. I have an example from 3 different high level programming languages here. So we know that, let's go back one. Your computer does not know what that is, right? Because your computer can only execute those 1 and 0s, those machine codes. All right, so how does that turn into machine code? That's the next kind of fundamental thing that you should understand. And the answer to that is there's 3 different ways. So some high level programming, I make some broad, I know there's some experienced people here, there's some broad generalities here. I know that, You know, I don't need the, well, actually. Okay. So. There's compiled, right, where you take C++ is an example, where you write your code, you run it through a compiler, which turns it into machine code, which can then be executed. There's interpreted, you know, the most common example, Python. And I know that's not true. None of you Python people get on me. But through Python, that runs through the Python interpreter, which then, you know, in real time, that thing is telling the operating system and the CPU what to do to make your application run. So what is the benefit of one over the other? I kind of covered it already. Just anyone have a guess? So remember I said those machine codes are CPU specific, right? So this C++ code that you compiled, it's only going to run on one type of CPU, on one type of operating system, and you have to, you know, if you've ever downloaded like a Linux installation executable, you have to pick which CPU you're doing. Does that sound familiar to you? Whereas software interpreted, you lose some performance, right? Because it's doing it on the fly. But that Python interpreter written by super smart people can, you know, they know what CPU you have and it'll send the right code to that. They know what operating system. So it's kind of like the right ones run anywhere thing. Not entirely true, but
So is that basically a compiler with a little extra intelligence to make assumptions about your computer's hardware?
yeah. Right. Great. Is that okay?
I just want to add, there's one other benefit to compiled language, compiler can catch some errors in your code ahead of time, so that you can fix them before you try running it.
Mhm. Yeah, you get some compilation time error checking, right? Because it'll know, it knows that you've done a bad thing. You know, modern interpreted languages, you also get some before executing error messages too, right? But not always. That's it's a tricky thing about that.
Is that a feature of the language or like an IDE that you might be using or what?
It's not a feature though. It's just a feature of the IDE, and we're going to get into IDEs. So. But then there's also a third option, right? Which exists because it's a healthy balance of the two, right? You get the speed of fully compiled with the flexibility of a fully interpreted, right? And that it adds an extra step. So Java is a great example of that. You run it through a compiler, you get an exe file. That exe file is not machine code. It's called Java bytecode, and that Java bytecode is then executed by you know, an interpreter, which Java called Java virtual machine, but you know, it's not like a virtual machine like you're probably thinking. And but it's able to execute that very fast. And this was like revolutionary when it first came out. That's why Java, you know, where Python is now, Java once was, right? These things change all the time. And it's important as text that you're keeping up with the latest, you know, and keeping up with trends. So another thing to keep in mind, I've already touched on it a few times, is that your application is almost certainly not being directly executed by the CPU. Like you're going through the operating system, and that's for security, that's for making sure that your application isn't interfering with anybody else's, and it saves you, right? This is a good thing. And most of the time, if you want to do real work, right, you want to do something on the desktop, you want to, you know, draw a new window, you want to output something to the console, or you want to open a file, read and write a file, right? Your CPU doesn't know what a file is, your operating system does. So when you're choosing a high-level programming language, there's some things that there are some common features that you should be aware of. And I'm not really going to go into these because it's kind of beyond the scope of this, but you could maybe write this in your notes or take a picture if you care, you know, care, it's fine. But I'm just going to show you two examples, and we're not doing any coding here, but I just want to show you two examples of, you know, some of the things on this previous slide. So this is this is a little snippet, and it takes an NMEA GPS string from your typical GPS, right? Which is, you know, you're probably familiar with NMEA. It's like text separated by commas. This takes that text GPS position and converts it to a decimal, right? Why do I like this? Why do I like this example to show you? One, because it's relatable, because you work on ships, you know what NMEA is for the most part. Two, these scary things at the top where, you know, even if you're doing like the most basic tutorial online, they don't tell you what those are, right? And we're gonna get into that a little more, but you're just like relying on your operating system to do a lot of chores for you, to access files, to write to the desktop. You're also relying on people who have already written code that does things that you need to do, right? So in this instance, you know, we're using system.math to use some math so that we don't have to figure out how to generate pi or round a number on our own. You know, you just say round it. And in this case, we're rounding a number to the nearest integer. I like that. I like that it's, you know, we talked about syntax in the last slide. This is C-like syntax. It's one of the most common, you know, all the curly braces and curly cues and the semicolon at the end of every line, right? And you know, I distinctly remember when I first started how frustrating it is when you don't know the syntax and you can't get things to work because you forgot. Not because you did something wrong, but because you forgot. But it comes to you, right? You got to stick with it. You got to, you know, the only way you're going to learn is by doing it and getting that muscle memory, and it starts to make sense to you why those things are there, right? They're not there for looks. Obviously, it's pretty ugly. And I also like it because it's got a couple of examples of converting types, right? Even on the last slide, so converting an integer into it, or the other way, converting like a decimal number into an integer and things like that. And it's not too scary, right? It's only, you know, 15 lines, right? So I also want to show you an example of Python, a different type of syntax. Like two broad categories. There's programming languages that are C-like syntax, like I showed you. There's everything else, right? And Python is one of those everything else. So a lot prettier, a lot less syntax, less curly braces, less unnecessary symbols. And what we're doing here is sending data out of COM port, right? And that looks pretty approachable, right? It's 25 lines, you know, there's even some empty lines, and to do something that's really computationally complex, sending something on a serial port, but that's pretty approachable, right? And what I like about this example is one, it's not an NMEA thing, so it's relatable. Two, you have another example of using other people's code, right? You don't have to worry about how the serial port works. You just say send the thing up the serial port. You know, you don't have to worry about NMEA because it's got an NMEA library that somebody wrote, or time. You know, how to say what time is it now? Put that out over the serial port.
I have a question, if you don't mind.
Mhm.
If you don't mind.
Yeah.
How do you get access to these other people's codes that are already pre-made?
We're gonna talk about that. Libraries. Also known as code that the people have written, right? To help you out. So to answer your question, sometimes it's included as part of the programming language. You don't have to do, you don't have to tell at the beginning of your file to use that thing because it's built into it. But often you do, right? And then sometimes it's something that you have to download externally, right? That's like you know, I'm gonna go through some examples, but you know, a lot of times you know, we're living in the golden age of information. There's a ton of like free open source libraries out there to do a lot. And there's also a bunch of paid libraries, which you know, sometimes it's worth it to pay the money to do something correctly and safely. And libraries help you do really complex things very easily, you know, 25, not even like to write something to a serial port is two little commands, right? Very approachable. Did I answer your question? Do you have any more?
Do they have, if they came to you, could they get examples of products and that sort of thing?
Right? So, an example is the libraries, and they all have like their own branding, because you know, it's just like how you get credit, right? And so like Pi serial, how you communicate using the Python programming language to communicate over serial port. Bootstrap is a very popular library to style web pages, you know, to make them look nice when you know, if you're like a Luddite like me, you can make something look pretty good. And I put PDF Sharp on there, because that's one that I actually pay for, right? Because it's a very good library for reading and writing PDF documents. You know, there's not a free alternative that is as good. It's worth the money. Actually, you know, that's Allison.
If you don't pay for it, do I also have access to it?
No. So. Another thing, so frameworks, right? This is another high level topic, right? The difference between a library and a framework they're also code that other people have written to do very complex things. And this is where I've seen a lot of people get confused is thinking that the framework is the programming language, right? And I'm going to go through examples of this too. So the difference between it's a little fuzzy, but the difference between a framework and a library is that they're often quite large, like to do very complex tasks, and they often have you organize your code, write your code in a very specific way to use that framework. And to give you some examples, if you want to write a Windows application, a desktop app, right? Not Windows the operating system, but something that has a GUI Windows with buttons and lists, and Qt is a framework to do that. Django, which you might have heard, you know, if you did Pablo and Chris's thing yesterday, Django is a very large popular framework to make websites using the Python programming language. Like Django is not the language, Django is the framework to help you get a lot of work done. And jQuery, a very popular framework to help you write interactive, it's JavaScript, right? So it runs in your web browser, but to make interactive websites that don't crash if you're using Firefox versus, you know, some other thing.
And so each of those frameworks has their own language, is that right?
Nope. Each framework, the framework is not the programming language, right? But the programming language is Python. The framework is how you make a website using Python. The language is JavaScript. The framework is jQuery.
Okay.
Do those frameworks work with all languages? So can I use jQuery and C++? So
No.
they're not.
No.
So there's.
So when you're doing your
for that.
research, and this is going to be in the advice section at the end, but when you're doing your research, you know, sometimes you deliberately pick one, like, you know, like we had that list of most popular. Sometimes you would pick one because they have a particular framework that will do the thing you want to do. So I think we'll answer that more later. But I haven't really touched on this yet, but code is it's all just text file, right? It's not, they're not special, they're not, you know, you can, all you really need to write a programming language is a text editor. And sometimes a compiler to compile that into something else. And so, or sometimes you need to install the interpreter, you know, you need to install Python before you can write Python. So, although all you need is a text editor, what you're commonly going to use is an IDE, an integrated development environment. Like you brought that up earlier. Okay, sorry, I'm looking at the wrong guy. So an integrated development environment is some software that makes your life easier. It's like Photoshop is for editing photos, you know, an IDE is for writing code and doing things easily.
This is where I get hung up a lot in
Mhm.
choosing one of these and bouncing back and forth.
We're gonna
Like,
talk about this.
their advice,
Yeah.
okay.
No, your lead just found the path.
Yeah.
Should do this more, right? So, yeah, it's software that helps you write code, right? And you have to kind of learn your IDE while you're, you know, I've seen like snobby kind of things where it's like, you don't need like real men use text editors and that, you know, use an IDE, right? Because and especially if you like decide you're really into this and you like want to get a job someday, you know, your company is probably going to be like, we use this IDE, you don't have a choice, you know, it's like, that's usually the case. So things that an IDE can do over a text editor is one, compile and run your code, right? It's not scary, it's just clicking a button. You don't have to, you know, that step I showed earlier where you have to, and then, you know, this will automatically launch that interpreter. This will automatically launch that compiler and just run your thing. Interact with the debug tool. And I wish we had more time to like kind of go through a debugger tool, but a debugger, especially you start doing some complex stuff, you know, it helps you go through your code line by line and see where problems are. You find like it helps you find the bug, do debug. And that's a whole hour itself, maybe next, maybe 2026, if there is a 2026.
Don't say it.
If we're all alive in 2026. There's a little built-in console in CLI, right, for put an output to your program just for testing purposes or your whole program might be just a CLI thing, you know, like maybe you do want to just write something that says low RVTEC. That would be great. And manage files and folders. When you start writing more than just trivial stuff, you're gonna have multiple files in your application and, you know, sometimes library files, like we talked about libraries. Sometimes you have to download that library and put it in a folder so you can run it. Still following?
Yeah.
Yeah.
I'll let you keep going because you're just about to answer my question.
All right, so there's several, again, you can't really go wrong with picking the top one, you know, and if you decide to do something else later, then you have experience to make your own decisions. Like by far the dominant players in the IDE field are Microsoft with Visual Studio, Visual Studio Code. This one runs on Mac and Linux. That's like basically the difference. And it's getting quite good where they're almost like on par with each other. And then you have like if you're only going to be a Python person, PyCharm is great. IntelliJ if you're going to do Java, MATLAB. Some of you, if you have science background, probably use some MATLAB, right? That's basically an IDE. It's a programming language and an IDE, right? So how do you choose a programming language, right? Step one is are you going to target embedded or PC, like just your average computer, right? They're running out of water.
You want some water?
Yeah. And my formal training is in embedded systems, so I love them. And I would encourage, it's not scary. It's like we're gonna do it. What is it? Embedded system on fire today. An embedded system, like long story short, because the lines are super fuzzy because we have just access to so many devices nowadays, right? But it's a single purpose computer that controls hardware, that does one thing over and over, really, ideally really well, not always, right? Great example, our sponsor, thank you for ice cream yesterday. An embedded system runs this thing, right? It's not a full-fledged like PC running in there. And I know that because I asked the engineer dude, I want to RVTEC. Your microwave, right? That thing's not running a full Linux machine. I hope not. Unless you have like a smart fridge that has like Twitter on it. Arduino, you've probably all heard of that, right? That's like kind of your entry level embedded systems. I wanna learn the super basics and like another device like a RBR Concerto, a really smart little CTD. They're pretty cool. It's an embedded system. And maybe do I mention this? Yeah. So if that's going to be your choice, you're gonna want C or C++, right? Those are the embedded. You could use assembly too, but typically with an embedded system, not always, but there's no operating system, right? You're executing code directly in the processor to turn an LED on it, and it's really not that scary. It's maybe we can do like Google embedded systems course for RVTEC.
Years ago at OSU, there was an entire afternoon, probably a training session. Everybody got their own little Arduino.
I was there, yeah, we did it, and it was at the bar too, which was the best.
Well, that was. Where I got my LED backwards and I blew it out.
That was that guy who went to work for Tesla.
Oh.
Yeah, he works for Tesla now. See where you can end up? That doesn't have as much cred now as it did like 5 years ago. So C++, they're not that scary, like syntactically a lot harder than Python, but you get used to it, I promise. You gotta dig in and do a lot of reading. Question number 2. Are you coming into an existing group of people who uses a certain technology? And you might recognize that. That's the late RV Ender.
Still good.
Legend, it was the best ship in the era. But I know when I first got there, Bill Fanning, very prolific programmer, very good programmer. We had a ton of stuff running on the ship that he wrote in VB.NET, which sounds goofy now, right? Because it's not even around anymore. It was deprecated, but VB.NET was once where Python is now. And someday Python will be, right? It's just like how things work.
It is, which is why when you write code, you have to be thinking in terms of how you're gonna keep moving that forward. If you write it in net.1, then next year there's gonna be a VB.2, and you better move forward to that next version and make all the changes necessary, or else when you get to VB.5 at for extinction, your stuff doesn't even run.
Aren't the computers do that for you?
Question number 3. I think somebody got at this earlier, right? When you're choosing a programming language, is there a particular library or was that particular language purpose-built for a thing that you want to do? Some good examples of this, if you want to do scientific computing, like chances are you could try to do it with any language, right? But if you actually want to get some work done, you're going to use Python, Pandas, Matplotlib, all those things. UHDAS is a prime example of that, right?
We started in MATLAB. Back in the day, I think the last one we used was R 2012, because that was the last one where you could have standalone license. The underlying stuff is all C, and Python does the GUI. It's always done a TKM to GUI that you put the buttons, but all the plots and everything used to be MATLAB, all of it. The database is managed by C, but all the plots used to be MATLAB, and around 2010, or actually 2006, Eric said we're gonna move to Python. Like, I can do something in MATLAB, I can't do anything in Python. But over the next 5 years, he chipped away at more and more and more of it. And then I went on a long Rebel cruise, and it's like, oh, I'm gonna do this. And that was what I did on the entire Rebel cruise, start chipping away at the plotting. with Python, and by 2011, we were doing everything in Python. And so, yeah, it's a long process to move from one language to another, but there are compelling reasons to move forward. MATLAB was gonna be untenable on the ships with the cloud license that you had to do back then. Without the network infrastructure, it couldn't go. And so that was the right call. Keep your eye on the ball and move in that direction.
And I just want to point out that, yeah, we talked about libraries earlier, so Python is the programming language. And it's MATLAB, those are libraries that you can use with the Python programming language to generate scientific plots, right? If you have a ton of money, you use MATLAB. MATLAB went the same direction as VMware a couple of years ago. Their licensing is just out of control, so they sort of shot themselves in the foot, right? You know, that's how you lose relevance. Do you want to make websites? That's a, you know, that's, I forgot to include a slide for this, but before you start anything, you should have a project in mind, right? Because doing random tutorials isn't really gonna teach you anything. You gotta have something that you want to build, that you're gonna be passionate about, because that's what's gonna compel you to keep going and learning. Because it can be, it's a challenge, but it's an approachable challenge, and you don't really need a background or anything to do it, right? So you want to build a website, you can use the Python programming language. I'm using a lot of Python because that's probably what most of you are gonna do, right? So use the Python programming language with the Django framework. Django's big, so that's a framework, right? Or the Flask framework if you just want to make lightweight web stuff without the whole like flashiness. Or PHP, a purpose-built language that builds for you know, running code on a server to generate websites. You want to make games, right? And the dominant technology in that field is the C# programming language with the Unity game framework. I'm just putting out examples up there, just to drive home the hope it's right. Do you want to make mobile apps, right? If you're going to do Android has its own programming language that Google made, Kotlin. That's because they got sued by Java. That's a fun story too. If you want to look at it. Android was originally written in Java. Java sued them. It like took forever, and then they're like, we're just going to do our own thing. iOS, they have their own language called Swift that you could write apps with. I don't think we have anyone in the RVTEC community who really specializes in mobile apps. That'd be cool. So maybe one of you out there can.
But I thought these languages weren't proprietary, so why would someone sue them? Or maybe that's a longer story, but why would they have to have their own language if they're open source languages?
Great question.
Yeah.
But that was part of it, that, you know, Java is open source, so we could do whatever we want.
Read one.
That's ChatGPT summarize.
So. Advice, we're at the advice stage, and I think there's only one slide, but I forgot the most important one, which I just mentioned, is have a project in mind, right? There's gotta be something on your ship that you wanna do, something that bugs you, that would be so much easier if it just happened automatically, or, you know, or, you know, if you don't work on a ship, there's something that you can automate to make your life easier, right? So find someone who you know, and finding a mentor is just because, remember that first slide where it's just the words popping up? Because sometimes you just need to know the right thing to Google to get through a roadblock, right? And it's hard, if all those words are just like made up words, right? And having a mentor handy when you could just be like, what? Like, instead of pulling your hair out for a week, you could just ask somebody and they could just point you in the right direction, give you the right Google search term so that you can break the logjam. Does anyone knows what that is? What's that?
What's the P?
Documentation.
Oh.
So read the freaking manual, right? That's what. All of this stuff has documentation, right? And you also sort of have to, because it is a new concept that you're trying to get a hand of. You also have to teach yourself to read that documentation, right? And at first you're gonna read it and you have no idea what any of that means, but you gotta teach yourself how to find information in the official documentation, right? And if your library doesn't have official documentation, that's a red flag, right? That maybe you shouldn't use that because it's not.
One more comment about that, the FM there, you can ask, Stack Overflow anything, and you'll come up with answers. 90% of them are pretty good, 10% is totally bogus. You can Google questions and you can get tutorials for things, which are often, relevant, but what he says is critical advice. You need to be able to read the documentation for that language.
That's a skill in and of itself, right? It's fine, getting through the documentation.
And just to add on to that, you know, reading the documentation is, if you go on Stack Overflow or some other website where maybe you ask a programming question and the answer is easily findable for documentation, people there might get annoyed that you wasted their time with such a question.
It's like
Or they
Reddit,
might
right?
find
Reddit.
it's duplicate in this document.
Any online forum just is a shooting gallery. Find a reputable style guide, like the syntax I was showing you earlier, right? Like there's usually, for all the big languages anyway, there's an agreed upon standard for how things should be stylized, what should be capital letters, what should be lowercase letters. You know, when to put a space on the, you know, so learn style guide as you're learning the syntax of the programming language. And you probably heard of GitHub. Like people throw it out during their plenaries all the time and don't really explain what it is. But Git is a management system for code, so that if you make a change, you can document that change. You can track issues. It's a very useful tool, not only for code. Like the multi-beam committee runs their wiki on it. You know, it's anything that you want, anything that is text based that you want to track changes on. And so learn Git early, because it's just, one, it's super handy too. Like eventually you're gonna make a mistake and you're gonna want to go back and you're gonna be like, oh crap, you know, that you didn't, I forgot to save a copy of that on my thumb drive or whatever. No, learn Git. It's not that hard. There's only like 2 or 3 commands that you need to like get started. You know, you don't have to be a super power user or anything. And I forgot to put on here, learn the programming language first. Don't, you know, for your first couple of little dinky things to learn, don't start off with like a huge framework where you're like, because then you're kind of learning the framework and you're not learning the core programming language. And this is my last slide. And this is so true, right? For anyone who's ever like done it, right? So the Dunning-Kruger effect as it relates to computer programming is like, you know, if you've never done it before, you're like super confused, and then you actually accomplish something. You like write something that actually does something, and you're just like, oh my God, I'm gonna fix every problem in the world. I'm so happy, right? And that's great because one, it happens quick. This is so true. It happens quickly, and it's like super motivating for you to like keep going and get better and better and better. And then you quickly realize just how complicated things are. You it could be demoralizing, but by that time you're hooked, right? It's all about that initial high, and then you're chasing that high for the rest of your life. Right? I feel like I'm like this guy right now. Well, that's the end. How much time do you got?
4 minutes.
4 minutes? Oh, wow.
Yeah.
Great.
Being one of those experienced people, is Python the way to go, or?
That's not what you wanna do.
Yeah, it could be. It could be.
If you want to contribute to that, if you're in RVTEC, you probably won't contribute to, or at least understand what want to read last and Coriolis and.
Something I found really challenging when I started using Python was understanding how to work with environments. So I think if anyone's like getting started with it, that's another thing to like fundamentally understand it before you really start right away. Especially if you're working in IDE, because there's so many times where you're just like, working in the wrong environment, and you're like, I don't know, on my computer, I'm pretty sure it's on my computer, I mean, not. But I found that challenging.
I was also gonna point out that many of us are, with academic institutions, and if you reach out to your institution or look at the resources available, there's lots of free training materials, tutorials, courses. You don't have to necessarily pay to learn, like this stuff is all available for free, and you find some really good resources available to you, so look around.
One thing, coming into a ship that's existed and has code that I'm now a steward of, like simply active. And maybe I'm looking for a perspective, but commenting is a big part of coding. And, you covered at the high level a lot of the topic, but you had a perspective on that because, as you inherit code, what is it doing? And how that applies to, there's opinion that you have.
Mostly for myself too, right there, because you go back several years later and you're like, what the heck was I thinking? And, you gotta like refigure it out, you get in that mindset, like, what the heck?
Yeah, I had a friend who used to live by the mantra, be kind to your future self. Figured that in a year or two, you're gonna have to go back and look at that thing and which level of innovative you need to lead so that you've got the right people that understand. Oh, we have another program back there.
I had a headache, but I remember what I want to say. I think this, that's so awesome, Eric. And you kind of kicked off like a couple side things you could do in the future. And I think if you, as you start to go up this hill on the other side, you're gonna be like spawning off projects on your boat. And gonna like seeding it into your environment, and it's gonna be awesome. And then you're gonna wanna see the presentation that Susan Tom put together. After like, way before I like how to start managing a software project group, and like what you should be thinking about, and how you're gonna maintain it. And so that would be like a good, I think if that presentation still exists, or the trusted, came out of trusted CI, it's kind of like how to do an open source software project for a major facility, and like as the things start getting complicated, there's more stuff. Like, it's super interesting.
Yeah.
So plug in, maybe that's like be something to do.
I want to add that, at least from my perspective, program language is just a way to express a certain algorithm that you have in mind, so I think it's also important, even from the beginning to learn how to think as a programmer and not just focus on learning one particular language. So maybe, plan out your project with pseudocode first, which is plain code, but really, as the name would suggest. And maybe learn about some other fundamental programming concepts like data structures. Those certain high level languages, a lot of them like Java, C++, Python, they all have similar features, like they all list arrays, they all have some kind of dictionary or map, they all have sets, they all have, some of you may actually know what I'm talking about. I don't know how many people are actually beginner programmers and how many are not, but, you should, learn features that are common among different programming languages, and that can make you a lot more flexible. For example, when you are inheriting a system that is in a language you may not be familiar with, you can maybe figure out what they're doing. Lots of train of thought. Yeah, so just learn to think like a programmer and don't just focus on one language role.
How useful or dangerous are there's a function at Google. That you start typing code and it kind of knows what you want to do and it'll fill it out for you. And so you don't have to actually look up the function or the syntax to do what you want to do. It kind of, it's like an AI function. It searches all the code that's basic and figures out what you need to do. Like, is that
a lot of those, the IDEs I was talking about,
Yeah.
that's a feature in a lot of
Yeah.
IDEs, code completion is
Yeah.
kind of Googleable term, but.
Yeah, I mean, as a beginner, is that sort of dangerous to try to do that? I mean, does it matter? Like,
Yeah.
I didn't know to type it out personally.
Yeah.
I mean, it's really useful to have some sort of intermediate level of that. So some of those things, if your language has syntax that has curly braces, if you type the left one, you put the right one out there for you. And that helps you think about where your block of code is.
Yeah.
Maybe that's easier than trying to remember to type that name. But if you say, for I equals, and it just splats out about 20 lines, that might not have been where you wanted to go.
Right, yeah.
Sometimes like ChatGPT, try to use that, it spits out stuff that looks great,
Mm.
and it looks like computer code. You're like, oh, this is perfect, and you put it into a compiler. You know,
Yeah.
it's just making something that looks like code, not necessarily.
I thought about including like a statement on AI. But tests, you're learning, right? Like you learn it, don't let AI do you.
Yeah, that's kind of what I was getting at.
Like,
Here's the time and place.
Yeah, if you're experienced, you can use AI.
It's a way to get to that first blip really quickly, you know, I mean, you can use AI, you can get to the top of that first.
Yeah, but you didn't, I feel like you missed out on that high, you know?
Yeah. Well, I don't know, you make it work, I mean, you make it work,
First chasing.
yeah. Thanks, Eric.
12:45, the whole go too far, right? That-
Yeah.
Well, last year, I for my.
Okay.
Thank you.
Great.
And then, yeah, I'll also, you know, so I can.
Yes, okay.
Perfect.
Look at that. Getting started.
Thank you so much. This is very overwhelming to see so many of you here. Thank you so much. My name is Lisa Hotelli and I'm with Marine Technology Society. And we're here to share about our Microcredentials initiative. So I have multitude of ways that we can run this hour. I have a PowerPoint, so we can go through what our initiative is, but I really want to get to this conversation and see what would work for the community. So has anybody ever heard of, I'll start there. Has anybody ever heard of Microcredentials before? Why can't I advance? What do I need to do to advance? Oh.
It's very easy once you guys start. That, well, there we go, right?
Yeah.
Yeah.
Perfect. Okay, so I saw a few hands up in the air, Microcredentials. Would you mind sharing your definition of Microcredentials? Because there's a whole lot of definitions out there.
I've already said it's a free credit card that covers a certain topic that you put on your resume, or say you've done this, on it, excuse me.
Okay. Anybody else?
I don't know if it'd be, it's not as defined, but it's very specific,
Yeah.
but, yeah, a non-degree course that shows like attainable skills.
Yes. Yes, yes. So we're hearing this, especially with universities, a lot of universities. I know one university that's doing 3 graduate level courses and calling it a microcredential.
Yeah, you're not for a graduate and undergraduate.
That's a graduate.
But they're both- It's three, yeah.
Right.
Yeah.
So there's a lot of different, like I said, language that and definitions that are going around there. So I'd like to start with just kind of listening to that and then telling you how we're defining it. So the microcredentials is much more in line with what you just said. And if I hit the forward button, yes, okay. So microcredentials, by definition, they came out of the computer science realm 20+ years ago. And it was a method for people because if you're in computer science, there's a lot of just-in-time learning, right? So it was a way for people to codify their skills that they were grabbing and using on a quick basis. So it was a way to just demonstrate and get qualified for their mastery of a particular skill. And that's the definition that we're going with. So it's short competency based. Now in the days of electronics, we have electronic badges that are issued that you can share to demonstrate your competency across a larger group. And badges can be added to resumes, LinkedIn, social media files, what have you. So the micro-credentials that we're creating can be stacked in various ways. So we're just at the beginning of all this. I'll share with you what we've been created, what we're planning to create, but we are just in the beginning of this. So we don't have a ton to create these stackable pathways, but that's what we're going towards. So these micro-credentials can be stacked so that the learner can build their own pathway. So build their own education. So yes, they could get their degree, but then they're stacking on other skill sets to enhance where they want to go with their professional career. So micro-credentials, they're personalized because of these personal pathways that people can do. They can stack and work toward a degree or a course credit, what have you, or they can address these skills. Maybe they go to one university that focuses on this particular technology, but they really want that technology that's down the road. So they can go grab that and add it to their resumes. They're flexible. So we definitely, as times are changing, people need much more flexibility in their pathways. Here's a great stat. How old is the average undergraduate student in this country? Average freshman, sorry. How old is the average freshman in this country?
30.
27.
No way.
A couple years ago.
Is that the median or is that the average, like your 4-year-old and 18-year-old in nursing? Is that
A 4-year-old?
40?
Oh, yeah.
Or
Sheldon's.
no, like is it, are you averaging the ages? So it's.
I can make that statistic. I would have to verify if it's median or average, and I read as average, so we'll go with that, but could be median. Yeah, so that takes into account for all the people that are entering the workforce and working full-time jobs, et cetera. So the typical freshman is not that 18-year-old frolicking on the quad anymore. The overwhelming number are much older. They have full-time jobs, they have families, they have responsibilities. So that flexibility is really needed by a lot of people to reach their eventual educational goals. And then it's performance-based. So basically you might not sit for an entire course, but you are spending a weekend, a week, earning that particular skill set, learning that skill set and applying it and getting credit for it. So you are getting your award for your performance and of demonstrating that skill. So these stackable micro-credentials, what we're trying to do is build out the workforce, the marine tech workforce a little bit to codify people's skills in a better way. So we are looking, the Marine Technology Society, what we're doing is pulling in partnerships. So as we create a particular micro-credential, the people that are sitting on the committees to pull the competencies together, we have at least one person from academia, one from the military, one from government, and one from industry. So all 4 sectors are being represented when we're pulling together the competencies in the first place. And that's to make these as transferable as possible across these sectors, or maybe if somebody wants to change jobs, they can easily still be recognized for their skill sets. So we're pulling together the competencies as the community, but then we're also partnering with colleges, universities, industry, the trainers out there to be providers of the micro-credentials. So we are looking to build this entire ecosystem to pull this off, and we've started. We are looking to directly address workforce preparation needs, and that's part of the conversation that we'll have in a little bit. And we want to improve the ability for people to transition their if they're in an educational institution to transition some of what they're already doing. So if you're taking courses, maybe that one course would encapsulate the competencies for 2 micro-credentials. So we're not asking organizations, colleges, universities to create new courses. We're looking to partner and figure out how these can be slotted in and stacked on the degrees or the credits that they're already earning. Okay, and so because we don't care about Department of Education anymore, I guess we don't do that part. Okay, so, workforce development, this, sorry, dark humor, sorry. This entire initiative was started with a grant from the National Science Foundation, because the National Science Foundation really did feel that this was needed to be addressed. And subsequently, we've also been awarded, money from NOAA, and we're working on ONR as well. So it was, like I said, funded by the National Science Foundation because they saw the need for this, these flexible pathways that I talked about and a recognition of skills. I shared this earlier, and as I am doing the roadshow for this entire initiative, I talked to some PhD granting institutions, and I'll hear, well, that's a lot of workforce for what we do. So, what I come back with is, okay, you offer PhDs, you have students that are using marine tech to earn their PhDs, of course, okay. So is every single one of your students using the same exact technology? Well, of course not, right? So you have everybody doing their own research with different marine tech, but at the end, they'll end up with that same degree. So alls we're doing is, like I said, layering on what you're already doing in a PhD prep program, master's prep program, undergrad prep program, and just codifying those skills. So really pulling out and putting a label on the skills that students are gaining as they're working through the program. We're not asking for it, like I said, not asking for more courses, more work, just identifying those skills and rewarding them with a badge that says specifically, I have this skill set. So there's a better fit for hiring after they graduate. And then we also need to build these partnerships, as I said before, to pull this off. So as I mentioned before, when we pull together the competencies, we've got all these different groups that are represented at the table. We have at least 1 or 2 people from each of these groups that give voices to it. And then it goes out for larger review from a broader set of people from these different communities as well. And we do a lot of tweaks, we test it a couple times, to do a couple beta tests to see if it's working, if it's not working, what needs to be twiddled in the background to make it work. So that's been going on. And then we have different groups. So like NOAA is super excited because they're like, oh, our people can earn these just by doing their daily jobs. Correct. Military, the military is super excited because if any of you have worked with the Navy before, we got a lot of enlisted, and a lot of the enlisted don't have that piece of paper, but they have all the skills that we need to do a lot of these jobs. But they're not getting hired because they don't have that traditional piece of paper. So we're also trying to level the playing field and get a pathway for people that are retiring from the military to be part of our community. And then the Navy Sub School is super excited because they need to retrofit their training, and we're working together to align with the micro-credentials that we are creating. So as they're earning their Navy certs for their training, they could be also earning their micro-credentials that will be better recognized outside the military when they leave service. And industry is excited because they do training all the time. So let's layer on some sort of recognition from training and academia. Yes.
So just quick question.
Sure.
So for like the military background.
Yeah.
Like how do you verify that somebody who's doing, or like in Noah's background, they're doing this in their job every single day, but they're not necessarily taking a course on it. How do you verify proof? Like, is there a test that they take to get the credential?
Yeah, okay, yeah, there'll be quizzes. So there will need to be a point person that will be awarding these. So as we're creating, and I have samples up here, as we're creating competencies, the teams are also creating a companion evaluation rubric. So that evaluation rubric can be built into a course, it can be built into whatever workshop you're doing, whoever is the purveyor of the trainer within the Navy or whatever would be that person. They checks the boxes and says, yes, that person has done this, but then there will also be some sort of back end check and balance on like quiz, what have you, and it won't be some really awful thing that the learner has to go through, but it is that check and balance because we don't want a rubber stamp nil, because then that will devalue the entire program across the board. So we're not trying to be super strict. Anybody who's in engineering, I do not want ABET. Has anybody gone through the ABET process in here? think anal probe. You do not want to go through that process, right? So we're trying not to do that. We're trying to make it more, just easier. Not lower the entry, but just easier process. And yeah, any other questions? Just, I used to teach high school, so I'm totally used to people not listening to me. And then also just jumping in randomly with comments, so go for it.
I was just curious, who would be the credentialing authority in that case? I mean, you've got universities potentially doing this, workforces. Like you mentioned the person, right? Is that person, who's the
The
credential?
Marine Technology Society will be the issuer of the micro-credentials. And we're creating these partnerships. So some people are just coming in and they're like, yeah, we're gonna adopt what we're doing and not be an official partner, but we're gonna do this and send you the names of the people that have earned this. So right now we're working, I'm totally honest, we're working on a friends and family network at the moment. So we are working with trusted people. I've honestly already turned away 3 different organizations that want to be part of it that a little too shady for us to be partnering with. So there will be eventually, as this program gets launched, there will be a criteria to apply to be a provider. And we will constantly check up with the provider, make sure that they are doing in fact what they said they would do. And then we'll also see that with that back end quiz. Because if those learners are not scoring well or passing that online quiz, then we know something is for. So that will be our check and balance. Again, we do not want to go deep audit on everybody because that's just, it's a heavy lift. And this is a very small community. You know, we're 1 degree of separation from each other. We might not know each other personally, but we know the next person and they know.
So people who have a lot of experience already, they theoretically like go on and take these quizzes and in 2 weeks have a whole bunch of badges to verify that they have these skills.
Correct. So that's how we're playing it, because it won't be open for everybody like that. There will be a gatekeeping process. But like I said, somebody put in 15 years in the Navy, we're not gonna ask them to start a foundational. They go on, check those quizzes, and then they show up. So we'll have foundational, I'm getting ahead of myself. We'll have levels, but yes, there will be that system. So you can just bang through a whole bunch of them and earn your certificate. Yeah. Or micro-credentials, I shouldn't say certificate. So again, we're looking for partners to be the local implementers of these. And then we have industry partners that are contributing to the creation of the micro-credentials to help balance what they want to see the people that are applying for jobs already have as resident knowledge, right? So we're trying to get this balance so it's not such a tension between academia and industry when it comes to workforce preparation. And we didn't know there was tension. Okay, so no. We're planning on 3 different levels and as I've said this before, this is a grant from the National Science Foundation. What do we do with that National Science Foundation money? We experiment. So please don't hold me to everything to this 10 years from now. We're starting the process and things might need to change a little bit. But this is working so far and working pretty well so far. So I'm not seeing changes immediately. We're going with this until it breaks. So we have 3 levels that we're working on right now, foundational, which is much more of a learning focus. This is someone who's even never seen this technology or maybe saw it on a Nat Geo special, like they have no understanding. So unless they are coming through and they're checking the boxes. So it's definitely a learning focus. They are just sponges, learning, putting their mitts on that technology for the first time. Really, they might be a great assistant to an assistant once they earn their badge. This is not someone that you would trust to do a deployment on their own. The intermediate is that push-pull. So you've got someone who does have a decent amount of resident knowledge, but still needs to learn more. Who was it that the, see one, learn one, do one? Somebody brought up that, schema yesterday. Same thing here. So see one, learn one, do one is basically the scheme here. And then the advanced. So we will be working with partners on the foundational and intermediate. And then the advanced competencies, I'm using that akin to a checkout dive if you're earning your scuba certification. So you learn your skills wherever, whatever pool, whatever school, and you show up to a quarry on X day and you show what you can do. And then you either pass it and get it. So that's what we're gonna do for the advanced. We're seeing that as someone just showing up for a day, day and a half. They'll get an assignment, a short project to do. and they'll do it. And we will have the instructors there to watch what they're doing, making sure, yes, they know this. Well, they might not, I'm so used to working with Kongsberg, I'm not sure how to work on this ecosystem. Okay, well, similar, you just need to twiddle that knob there and you're off to the races. And as long as they know what they're doing on the back end, we're good. But we will offer a little support because not everybody knows every single system that's out there. So that's the approach we're taking. Again, could blow up in our faces, but this, everybody right now thinks that this is the way to go, so we're gonna go. A graphic from the proposal, how we're building the workforce. So it's the concentric circles and just stacking and building and building and stacking till we get to this and just showing the variety of knowledge that's needed from a marine tech. Y'all know this, preach to the choir on this, but not everybody who reviews a proposal for NSF knows the hard work that you do. Okay, so the micro-credentials that are available right now, we have foundational glider hardware, foundational glider software. That was broken specifically because looking at ROCs, remote operation centers coming online, especially the Navy and whatnot, we didn't want those hardware and softwares to be so inextricably linked that people couldn't earn it, because if they fly gliders, they might not ever touch the hardware. So we didn't want them to be so coupled. We are asking that if you're going down the glider hardware path, that you at least earn a foundational in the software and the piloting. If you're going down the piloting path, before you earn your advanced, software, you have to do foundational hardware. What's it more? If you haven't noticed, we're related. It's my nephew. He's a student up the hill in the summer days. And he's earned his foundational sonar and ROV, right? No difference. And then we also have foundational deck ops that is available. And that, I mean, I think all of these are important, but I really did want to talk to you all about the deck ops when we get there. Just a few quick, what's in development. Intermediate glider software, that will be an online experience. We're using a simulator. Advanced glider, still in development. Advanced multi-beam, already hit up the multi-beam group to help us. We are looking to develop that and hopefully run a pilot of that in like March this year down at USF. And we have foundational prototyping that is in collaboration with OSU, and that will be ready pretty soon. And foundational floats in collaboration with the International Argo Floats Group and UW. So that should be ready soon as well. And then what I'm developing online is that kind of laying out the nuts to get this world to come a little bit closer to us, right? So what is the blue economy? What is marine technology? Those will be totally different badges that someone just logs in online and works through. It will be a different shape, style, everything badge, so it won't be conflated with the hands-on learning ones. But it's just that pathway to bring people in, to make them aware that this is a thing. Because so many people don't even know that they'll see something on that geo, oh, that's cool, and not realize that this is a job they can do. And then our partners, we're cultivating an entire network, and I'll go through. These are all people that we're in active discussions with through various, and you could be sitting right next to someone at your university and not even know this is happening. So if you see your name up there and you're not aware, please come talk to me and we'll try to make those connections internally as well. So we do have Stockton University signed their paperwork last week. They're already on the way, and everybody else is in process. Plocan, if you're familiar with Plocan, I'm in negotiations with the Spanish government to pull that one off, so I need to beat, but we're getting there. And so again, just in going through, we're gonna award these. Badges will vary in length of time depending on the level and the complication of the marine tech that they're actually using. We know that some is more difficult than others to operate. And awarded by MTS to the partner schools, and the partner schools inform MTS who has earned, and then we award, and they can be assigned alongside local badges. If you're already doing a local micro-credentialing effort, happy to talk about that as well. And then they're developed. Okay. So another reason why I'm here, recruitment time. Anybody who's interested in this initiative, I would love to hear from you, love to pull you into this entire process. We are working on a whole bunch of concepts and ideas for micro-credentials in the future. As you're well aware, and much marine tech is out there. We're working on data. We're working on a whole bunch of other topics to pull in. So I definitely need people to be part of the teams that build these and then also review these. Recruiting partners for the micro-credentials that we already have. And then we also have student summer experiences through this grant. I have one more year at the point, clock's ticking. But if you have students or you know of people who want to attend these camps, please let me know. And we pay for their travel and attendance for the camps. So that is the PowerPoint. Are there any questions in addition to what was already discussed before we get into conversation? Yes.
I'm curious about looking at your micro-credentials. They all seem very specific to like proprietary systems. Is there any talk of doing broader topics, for instance, rigging, wire terminations, things like that?
We saw the deck ups one. That's what I'm here to talk about.
So the deck off.
Yeah, that's where I'm seeing it, but it could go somewhere else.
Yeah.
Exactly, yeah. Because deck ups, and I'll share with you the competencies and the rubrics, that's definitely so foundational. It is a college student working, stepping on a working boat the first time. And how not to die is basically, it's so low level.
Yeah.
You know, Coast Guard does their thing. We don't want to cross paths with them. We have all these organizations that do their own thing and we're not there. What we want to do is help fill some gaps, especially like the research fleet and what you do. How to properly deploy CTD skill sets, rigging, things like that. Like there are other organizations that do things, but whatever we could do to help fill those gaps, that's what we'd like to do. There. Yeah.
So if I'm hiring someone and they list a bunch of badges.
Yeah.
Right? Can I simply go to MTS and look up if they're real, or like, how do I like, put them?
They wouldn't have that, well, yeah, I guess you could break anything these days, right? Yes, you can always call us. We have a database of who's earned what. Some, we are using Accredible. I forgot to mention that. If you're familiar with all these badging systems, we are using Accredible. So you can click on that badge and it will give you the metadata about what they learned and earned from that badge. Accredible is also offering transcripts now. So just like college university, we can generate a transcript that will be more detailed about earning that badge. Some of the badges, the community that I've talked to so far, and I'd love to hear from you on this too. The foundationals, it's been made akin to like riding a bike. Once you learn, you kind of got that life skill. You could be a little rickety 10 years later when you get on the bike for the next time, but you got that skill. So the foundationals, so far, the community has agreed that the foundationals will never expire. Once you earn it, you earn it. The intermediate and advanced are totally different. We will have timestamps on those, and then it will be technology dependent how long those timestamps. So the teams will make those decisions.
As you grow this program, are you going to potentially be like trying to stay with very discrete, like hard trainable skills? Because I find often in hiring, it's like, I can get you whatever training you may need, but if you don't have certain soft skills, an aptitude for learning, like how to troubleshoot. Like that would be a badge as a hiring manager. I would be very curious to know if they learned in a troubleshooting badge, because that can be applied across many different systems.
Absolutely.
Or like electrical troubleshooting.
Correct.
Or things like that. So is that something like in your field of vision?
Absolutely. How it plays out, we're not sure. And that's another question, because I think this is the perfect crowd to ask that question. Because with each one of these, troubleshooting comes up every single time. Well, do we fit this in? Do we not fit this in? Electrical, how does that fit in? Something really simple. Well, we can't embed in every single micro-credential. You need to be able to use an anteater. It's just gonna slow everything down. But how do we make those pathways? And then we also envision some of these badges having pathways. We should nudge this one too to complement what we're doing here.
Or like take like this Coast Guard certification.
Correct, that's our stuff, exactly.
Because that would
The
be really
community wants this, by the way, so go off and get this too. We're not gonna offer it, but seriously consider doing this. Yeah, and that will be part of the pathways that are built eventually.
That,
Yeah, I think the troubleshooting is really.
I would love this to come out of that. Yeah.
Anyway, I was still.
Well, that's, I need every MacGyver award winner. But that's what you see, right? It is, it's MacGyvering, and all of us, when we're on deck, we've all been in that spot, and just like, I don't know, and groupthink, and that's what I'd love to see too, is like, for the advance on that, just a total groupthink. Who was it yesterday? We were talking about, oh, Tara. We may have been terrorized. We both did this, we were running these, hands-on stuff, and we would go in and mess with some stuff on a Sunday afternoon, and then we come in like, oh, my thing's not working that anymore. And we knew what we did, that we can undo it if they could figure out, but it was troubleshooting, like on the spot. You left it on Friday and Monday morning, it's not working. Why? Yeah, guess what? That's life. And just kind of messing with them.
I terrorize.
Right. So things like that, I think, and you know, you don't wanna mess with people too much, but it's real. Any other comments, questions? All right, yeah, sure.
A little aside from your presentation, but membership. So MTS is a membership, is membership implicit in earning credentials?
Yeah. At this time, I am very strident about that fact. Others disagree with me. But I think especially in the beginning of this, when we are collecting taxpayer dollars to create the system, I feel very strongly that MTS should not be that proprietary about this. However, we do, the foundationals will be $50 to earn. The advanced will be 90, the intermediates will be 90, advanced will be 250 to earn, and we need to figure out a way to collect that fee. So what I would like to do, when we had that conversation before, is MTS does offer institutional memberships, where your college, university, organization could sign up as an institutional membership, and as a result, you get X amount of people that are automatic MTS members, and then we could bake those fees into that annual membership. Or we have other, like Stockton is becoming, that slide's not there, Stockton is becoming an official partner, so our badges are co-branded MTS and Stockton. And they will pay a fee every year to be a provider of the microcredentials, and their awardees get that co-branded badge. Or we have people that are just like, yeah, we don't wanna go with this, we just wanna award them, then we need to figure out how to collect that money, because I do not have the time to chase every undergraduate to get their $50. So we need to work out with that model. The pressure is to eventually make all providers an MTS member. That's pressure that's on me right at the moment, but I strongly feel that at this point, we shouldn't lock it down that much.
when you go to collect that money theoretically, we're just doing it after they've passed the exam or quiz, like, or do you collect it at the beginning? And then you get a certain number of tries to pass.
Yeah, so we are working with the institution, we're not working with the individual learner. So the institutions, depending on how many microcredentials they think they're going to award, we were doing it, so a Chuck E. Cheeseified it. So when you go to Chuck E. Cheese, you get your tickets, and tickets are different things. So you'll get X amount of tickets every year, and then you can apply them however you want. If you have the majority of your learners are intermediates, and they all go to the intermediate. If the majority are foundational, then you can award more because the foundational are worth less tickets. And that's how we're doing it. And we will work with you to create that level of how many tickets, how many microcredentials you will award. And then some schools are baking it into their course fees. Some schools are taking it from their overhead, their lab overhead accounts. Different schools are doing different things, and we're leaving it to the schools to decide what they want to do, because it's local cultures, local state laws, like we can't get into that. But we want to hear other models. If you think none of that's gonna fly at my university, I want to hear that and figure out what we can do.
Is all this pass, no pass, or do you see value in even doing it system?
It is. It is pass, no pass. However, that's where the instructor, the local person who's doing the awarding. So I'll give you an example. We worked with a workshop that we did at USF in the spring. They were late in pulling that together. So all the people that signed up for the workshop had classes, had this, had that, so couldn't stay for the entire thing. So we have a list of them, we had their rubrics filled out, and then we invited them to attend this course, be on this cruise, and multiple opportunities to make up for what they weren't present for, and to demonstrate their skill set. And a lot of people caught up that way. So we are flexible in trying to figure this out because life is life. But there will need to be some, we can't get that person 3 years from now come back and said, oh, I did this cruise, that's not gonna work. So it is pass fail, but there are qualifiers.
It seems to me that the greatest value for this would be people at the beginning or intermediate career levels. Whereas, you know, when you get to more of an expert level, it's hard to really show, I'm a rock star. You know, this person is really honed in this skill.
So, I mean, with the advanced, they're just gonna show up and get it. Would you suggest a different model for that? I'm not gonna give out gold stickers for rock stars.
Yeah. Yeah, I was thinking about it more, but,
I don't need to put you on the spot,
Yeah, no,
I'd
I'll
love to
think
have this
about it,
conversation, absolutely. And that's where this model, I mean, we came up with this general concept and it's been tweaked and refined as we talk to the community to learn what's gonna work.
I guess what I'm getting at is that, like, you know, could I sit in a classroom for 12 hours and on paper show the same level of competency as someone who's been doing it in the field for 10 years? Because they showed up and got the same credential.
Oh, I see. Well, it's hands-on, it's not just on paper. So, yeah, there's a bit of paper, but there's a lot of hands-on skills, and that's where we're trying to level the playing field, honestly, a little bit. Is to get those people that do have that 15 years experience, be able to walk in and knock it out of the park. Without sitting down for an entire course to demonstrate what they're doing. Does that make things clear?
Yeah.
This is more of a statement, I kind of answered your question, but when we did that workshop, the thing that turned me from a skeptic into a believer, but it's pretty rigorous. To get that advanced, you really need to know your stuff and
Yeah.
like, it's not something that you're gonna sit in a classroom and pick up. It was pretty hardcore.
Yeah, but achievable, like, we don't want it to be just the cream of the crop early.
Yeah, if you're an expert, it's like.
You're an expert.
Would the advanced ones that are in person, skill-based group, I'm sure you're invited to a postcard first, I'm like, okay, I can do it on these days with these locations.
Yeah.
Is it that type of thing?
Yeah.
So there's not like a centralized location I can go at any time, it would be a listing of the course offerings?
There could be, I need a bit more of the community say, yes, we're doing this to commit to something like that, but right now I have several organizations that they're on the air and said, yes, I wanna host one of these. So right at this moment, it will be more pop-up, but I would love to get a continuous schedule, like, had this discussion with Navo. How we could have, as their sailors cycle through, we could have maybe every 2 years, this workshop there, and then this workshop there. So that anybody from that region could fly in or drive in, whatever, to be part of it, but it would be more for the sailors to get them up to speed. Norfolk, Groton have offered the same thing, and then a couple of universities put their hands up too.
I'm picturing like, for instance, you had that 681 termination birth, that may be a little too neat to have a 681 termination credential, but if you like the course offerings or training opportunities that we offer tax per year.
Yes.
Is like lined up with a credential offering.
Yeah, absolutely, we talked about that with data and a few others in the multi-beam. Yes, we need to talk about that a little bit more. So right now, we've been focused on topics that really go across the board. And then there's some that are really needed by a small group.
Yeah.
right? And where is that line and what can we do? And we don't want to cut you out. And if that's something that every hand goes in the air from the UNOS community that says, yes, we need this, then to me, that's critical mass to actually address that. If we get 5 hands that go in the air from the UNOS community, we can't really address that. But I think what I mean, just what you were saying before, the rigging, the cables and connectors. I mean, MTS has a cables and connectors professional committee. We're invested. You know, so those types of topics would be of value to our large community as well, and be of value to you. So trying to figure out where that break point is, to support you, but also support the market.
What about, I'm adopting.
No.
One more question. What about, topics that are already offered by like ABYC or I'm thinking like, there are like little kind of like micro credentials for fiber optics. Is that something you would consider duplicating or?
That's what we need to talk about, is things like that. Yeah, so we want partnerships. We're MTS, and I just want to lay this out. MTS, we're not trying to own this space whatsoever. We're trying to fill a need that we see, and we're trying to build partnerships. So we're building a partnership with THSOA. So we will be creating micro-credentials collaboratively that build a pathway to earning Cat A, Cat B. And then we're looking for partnerships. So, and then AUVSI is another example of another organization we're trying to do. There is plenty of space for everybody, but we also don't want to be duplicating what others are doing. If there's opportunities for partnership, absolutely. Absolutely. There are needs by the specific marine tech community that are slightly different than how other people might use that same technology. And that's worth exploring, to exploit that. Yeah. Does that make sense? Like, there's a lot out there that we can be doing. We can't do everything at once. We started with some of the big chunky things and then we'll go more niche as this develops. I've only been at this for a year and a half, so give me some grace. We've done pretty good in a year and a half, but there's so much that can be done. There's so many topics that we all deal with on an everyday basis that can be broken up into these micro credentials. And like you said, codified learning that's already happening out there. Yeah.
I was gonna suggest that one way that you might solicit ideas would be create some kind of survey and send it to the RVTEC mailing list and let people respond, like, I wish there was training on this.
We were talking about a survey. I didn't think about sending it out that way. I love it. And I was gonna turn to our whiteboard behind us too, to start that conversation as well. But yeah, that's great. Absolutely. Happy to do that. Are there any other, I do want more conversation instead of, I want people to talk in small groups. So I do have information about the micro-credentials. I've got examples of our competencies and our rubrics. So to kick off that conversation, would it be helpful to look at those for a few minutes and understand, like, get some mental markers around what we're doing? And then we can have this conversation about other topics. Does that sound like a plan? I want to do what is fruitful for you. Well, I should stop. Let me draw that back in. Does this remotely sound of interest to you? Yeah, okay, all right, then let's go on to this exercise. Because if it wasn't, that would be a waste of time. All right, so I have the foundational deck ops, and I've got 10 of each. And what I would suggest is that you definitely grab a competencies and an evaluation rubric together so you can see how they come together. I'm not sure how to do this. If you want,
We can take one at a time.
sorry. Yeah. Okay, so we've got deck ops, we've got our non-work class ROV. Did I say that strongly enough? Non-work class. When I'm working with oil and gas, I hear it, so just saying. And then, what's this one? Sonar, foundational sonar. And then we've got the foundational glider. So we've got hardware and software with glider. Do we want to break up into groups to talk about individual topics? Is anybody super passionate about one of these technologies that I mentioned.
How would you say that down?
Everybody's. So what I could also do is figure out how to project the DevOps too, because I've only got 10 paper copies of that.
Good idea.
Okay, and then, do we want to, so I'm leaving it to you, how do you want to divide this conversation? Or do you want to group around particular technologies, only want to talk about DevOps? Like, what's your interest? Gliders, we got a glider group? Okay. So if somebody wants to put their hand in the air and say, I want to talk about. Come on, DevOps. I heard gliders. Do we have any ROV interest? We have ROV. Do we have any sonar interest?
Would be good too.
Are you on the back there? That's all right.
Alright, how do I find your, you need to put it up here.
Well, I mean,
And then really Okay, cool. Yeah. Really.
The desktop, but then with me.
Yeah, okay, thank you.
Sorry, when you
Alright, let's keep an eye on
So you've got to be pretty much average or better.
Yeah, I mean, it's a lights. It's just not.
You get anything around. Rolling precautions. That seems like. All of your tweets and money.
Right, yeah, yeah.
So depending.
Right. Yeah.
On my machine. It's working away. Power connector.
I like it.
How do I get it to?
Yeah.
Why is one of them whole?
General skill set has lost the industry, it's like, we're across the technical spectrum. And this is like, lighter specific or, specific.
I know hammer the out.
That's
Right. Yeah. Oh, yeah.
I know those three letters.
Right. No, but it's the. Right.
Oh, there you
But I think that my question getting at, you've got brain or two brain tax on or shit. Yeah, they need to be able to play or yeah. They need it. And it's interesting this being necessarily having experience.
Yeah, there's no multi-beam.
Right. Yes.
That's me right there. I'm like, okay, we got a set. And then you go to another port, like, oh yeah, I don't have any more.
Right.
Awesome. Thank you so much. Let's see if it works. All right.
All right. Not too bad, right?
No.
Okay.
Okay, so for those of you who don't have a paper check box, you've got it.
Yeah, and I get them.
Okay, folks online, I need to find a way to share with you. Sorry. There you go. No, I can't.
Well, you only have 9 minutes. Okay. If you're talking, that's.
Oh, I think people are really interested. I honestly do. And I think it could be just what this community needs because people come through. They really want to do it, but they need some sort of little something to get going. This is what the new internship is, right?
Well, and that's why we can certify all those internships, the interns that come through,
And
not
so for-
motivational at least.
And I think that it's nice to have another avenue for young people, because like graduates or undergrads who make the they can shift. And so it would be great for them to have this sort of other credentials, you know, something that says, yeah, this person does kind of know what they're doing, right? And
not tied to those.
yeah, I like so if, let's say, oh, shoot.
Yep.
So Stockton hosts a course, is that right?
A course, a workshop, whatever it is.
Okay, and then anyone hopefully can come.
Correct.
But Stockton would charge, right?
Correct.
Yes, okay, so, okay, and so then they get a credential.
But
Yeah,
it will
some
be
places-
the same credential,
Yes.
whether it's Stockton, Rutgers, UW,
Right.
because it's all the same competencies and evaluation that we're going through.
Right.
So it doesn't matter who the provider is, as long as they're doing their jobs.
Right.
It doesn't matter who the provider is, that student will get maybe a local twist, local flavor to what they're doing. But they've got all the same basics. And that's the goal behind all of this.
But again, I guess you.
Well, Seabird's interested in these
Interesting.
and
Okay.
going down that route as well.
Okay.
Provide all the training on them. Correct. Correct. So that's right. There's, like you said, it's an endless list of technologies we can be addressing. We had to start somewhere. Yeah, it's where we started and I want the inventory, people want that hit list, and that's what I'm building is this hit list, and that goes into the next one.
Yes.
So that's working with the Navy. We partnered. Yeah, so partner with the sub school, NAVO and the academy to some kind of proposal. And we went into ONR and leaning in. Correct. 2 weeks ago, it was great.
Yeah. Life was good. Right, keep safe. Still on the same thing. Well, good for you. I mean, though I will say that this needs some of the buzzwords, workforce development. you
For
know,
sure. And that's why I
making
feel-
a blue economy, everything like that, you know.
And that's why we're
Building
building
on the-
everything that's that. For an MSF range, it's like, oh my God, we were one of the few that got through with no questions asked whatsoever. Then their conference grant got blocked. Same thing. They're like, no, this is great. This is all workforce development. I got a conference grant this summer
Really?
on this.
Wow. Nice.
So it works. It's just the right buzzwords with the right, yeah. And it's not, I'm not lying. I'm not lying. I'm not repurposing. We're doing what we're doing. We're just using words that they want to hear. So I don't feel like I'm filling my soul. It's on to we're getting towards it.
You will appreciate this.
Sounds like that.
We could find. So,
And I
yeah.
have stipend too. Now that they're excited, I'll dangle that.
Yeah.
Okay, so. Sorry that was short, but we've only got 5 minutes left of this session. You all had such a great time, didn't even know this. So a couple things I want to do is harvest this information from you and then figure out if you want to be part of what we're building. I've got business cards, you can get in touch with me. But then I did want to mention that, is anybody going to Workbook Show in a few weeks? Okay, so I'm running a meeting about this at Workbook. If you want to go, or if you're thinking of going, please let me know, because I do have a little bit of travel support as well. This is an NSF grant, conference grant, and we're talking about microcredentials, but then also we're pulling in a lot of schools that offer electrical, IT, all these
Right.
other skill sets that we need, and what do those people need to do to twirl the knob a little bit to enter our space and be aware of these jobs. So if you want to go, happy, it's gonna be Thursday afternoon. I'm serving lunch and snacks, so just saying. Anybody else is interested, let me know, happy to have you there. If you're interested, like I said, let me know. I will say, I'm happy to share this stuff. I've already had to fight back 3 different times where people have said, oh, this is great, I'm gonna take it and do my own thing with this.
Oh my gosh.
Thank you for that response. So I am happy to share this, I am happy to email it, I want the good faith that we're gonna be working together and build something bigger and stronger together. And not just take it, because that just devalues everything. If everybody spins off in worldly dervishes, we're never gonna build something that helps the entire community.
Right.
And this is all community, this is the community's IP that's going into this. So that's why I also feel strongly if somebody just takes it, they're like, this is great, you're stealing the community's IP to do your. So, sorry. Were there any ideas of what people want to do for topics of micro-credentials? Or did we just talk about other stuff?
Just because I'm still a little confused on it.
Yes.
What are the steps someone needs to take? Like they need to go on the website and find a provider.
Eventually, yes. Right now, we only have a few providers, so we're building that network to be providers. So then the providers, and that's, I look to all of you in the room to bring your home institutions to be providers as well. Then we can either integrate it into the courses that you already teach. The interns that come on the ships could earn these. You could offer workshops, 1-week workshops, 2-week workshops for people to come to your facility. You charge them to be part of that workshop. So you're earning money and you're offering micro-credentials. But yes, eventually they will all be listed on the website once we have a bigger network. I really don't want to shout from the hilltops about a network of 3. I want it to be a little bit more robust, people. Yeah. Any other topics that everybody's like, oh, we gotta have this? Like, I can't believe you're not even talking about this topic. Is there a CTE? You want to?
Okay, yeah, because I thought maybe it was under the deck ops, but I didn't see it there, so I didn't notice.
That's why I would love to grow the deck ops. So right now the deck ops is 101 how not to die. And what I want is the intermediate to start going into things like that.
I feel like maybe. Yes. Like separate, or the deck ops, like, you know,
Sure.
Yeah.
certain things, kind of, that would continue with other, estimates as well, like, you know, taglines and stuff, so that, with deck ops and rigging and deck safety.
And an extra point, you know,
Yeah,
like, you're going deck ops, but make sure to check out CTD.
Yeah, and then you mention it. But I think like there's so much involved in CTD, like it's how you take bottles, or then
Right.
that information, if you're like, 5 or the highest level, you know, like you're good. 322 termination.
Right, and then that post.
Yeah, and then there's the software side, I feel like it's to know both sides of design and deck side, like a master's stuff.
But I think kind of more abstracted than that, of just like sensor and data comms, serial communication protocols,
Wow.
you know,
Yeah.
data collection systems.
Yep.
That like, not just focused on CTD, but like just
All sensors.
sensors.
Absolutely. So it's interesting that you said that because sensors was in that original proposal. And the reviewer said, there's no way you can talk about sensors. That's ridiculous. So we were asked to extract that,
Interesting.
but that was in our original. And
Dr.
then
Julie.
I was saying, Seabird has already approached us. They want to be a partner in this as we develop this. And we want others. It's not just going to be dominated by one industry partner. We want multiple industry partners at the table, so it doesn't end up being commercial for one. We want to make sure that all voices are there, but we'd love to talk about sensors, yes. Any other ideas? But please email me, let me know, noodle on this.
You go to like another institution, they're like, you can't use our forklifts, even though if you have like tons of experience using forklifts somewhere else, like.
That's beyond our scope.
I love it. I would do it.
So thank you again. Please be in touch. Please think about being on one of our committees. If you have ideas about other concepts, please let us know. We're here to listen. We're here to partner. We're here to help.
Yeah.
But thank you. Thank you so much.
And it's. I just want to. Oh. Just that.
That's something. My brain, sorry.
Mental picture in your mind of how winches specifically work. Because in my experience, I mean, that's 90% of the problem of troubleshooting. If you just have a good mental picture of how these things work in general, then you're good ways towards fixing any problem that you might have with the piece of equipment. There we go. So, to get started here, we're gonna start with a theory of operation for a simple winch. So the simplest of winches is gonna have some sort of power source, first of all. Some sort of control system. In this case, the simple control system is just a control lever. It might control fluid going in and out of the motor if it's hydraulics. Might control the flow of electricity to and from an electric motor. Motors in general tend to be high-speed, low-torque things, and most winch drums need to be low-speed, high-torque things. So I put gears here, but some sort of mechanical reducer. It could be a chain and sprockets, it could be gears or anything else. Oftentimes the winch will have a clutch of some sort that disengages the motor and or gears from the drum, so you can spin it freely. Not always, but sometimes. There's generally a brake. Hopefully there's a brake on our winch. And of course, the drum and the tension member we're going to wind up on the drum. So on our simplest of winches, my question's been put off. So on our simplest of winches, what sort of problems do you foresee having with this winch? Let's say you move the control lever and nothing happens. Nothing happens, there's no sound. What sorts of problems do you think might cause that?
It's plugged in.
Maybe there's no power source. I mean, if you have a power source and it's going to the motor or to the controls, if it's pneumatics or hydraulics, you might hear something whooshing or something. If it's an electrical power source, you might hear some sort of humming or high-pitched noise coming from the motor. That might indicate that everything's running, it's just not engaged with the drum, so it might be a problem with the clutch or the gears. If you hear no noise whatsoever, then you might just not have any power going from the power source to the winch. Typically, when we're going to troubleshoot a problem with the winch or any problem for that matter, you want to look at the low-hanging fruit first. The things that are really easy to check, is my brake on? Something to that effect. And then move to your more difficult things to check. So, moving from our simplest of winches.
Can I ask you a quick
You
on
can,
that?
yep,
The power source thing,
yeah.
Grounding, would that affect the operation or is that just more of a safety?
I gotta be honest with you, I'm not an electrician. But.
Cause that big Godzilla guy had.
Right.
has a big grounding
that-
bar out there.
yeah.
And,
Yeah, no, that has to be attached to the winch deck, to the working deck or something like that. One reason for that is, obviously, if we get that's not mated to the deck in any way, that guarantees that you're not a better conductor, than whatever connection there is between the deck. And, we definitely have, on the electric winches, we have a grounding strap because, those winches create there's not just 480 volts in there like you might have in a ship. Any random piece of equipment, there's actually frequency drives in there and those generate thousands of volts. So we don't want water getting in the control system or something and then electrocuting somebody. So, and when those particular winches were designed also, the resistor bank wasn't necessarily waterproof.
Oh, yeah,
So there
basically
was an
don't
issue.
operate if there's water on the deck.
Right. So that's not the case anymore,
Okay.
but now they're waterproof. But there was that problem too. So, yeah, does that answer your question?
Fine, I mean, it sounds like it would still work, but. it would be-
Oh, yeah, if that grounding strap is not on there, that winch will operate.
Yeah.
But if something that's completely electrically, we do want a direct path that doesn't involve you to the deck. So. Dang it. Okay, so I have, here's a perfect example of our simplest of winches, these little Ingersoll Rand tuggers. We've got our control lever on the right-hand side there. Just next to it is an air motor. You can't really tell here by looking at it, but there's a shaft that goes from the motor through the winch drum. There's the gears over here that then get engaged with the winch drum. This little handle here is the clutch. It disengages the gears so you can pull a line off that drum if you want to, or what have you. And then this lever right there is the brake. It's a manually operated brake. So the simplest of winches. So we're going to, that's just kind of a cutaway view of this winch showing this shaft that goes from the motor. Damn it, I touched the cable. Don't do that. There we go. It goes from the motor on the right-hand side through it, and then, it seemed like a good idea to include this, but it's actually kind of hard to determine what's going on. There's one small gear mating to one big gear, mated to another small gear, and then the inside of that brake drum is the other gear. So anyway, so there's the simplest of winches. And then I went backwards. I'm sorry. Okay, so we'll add a degree of complexity, not that way. There we go. So we'll add a degree of complexity. So our simple winch might work okay if we have a tension member that's really round or really big compared to the drum. Solid like a cable or a wire rope, not as much a line. Those sorts of things tend to go ahead and wind themselves on the drum fairly neatly all by themselves. It works okay if there's only a couple layers. Once you get into a lot of layers, things get kind of ugly if there's not a level one, which is what's on the right-hand side there. Adding a degree of complexity might be a level wind, and the level wind in this case consists of what we call a diamond screw, and I'll show you a picture of that in a second, so it's more clear what a diamond screw is in case you don't know. A diamond screw is basically a rod that's got a helix cut in it, going in one direction, and then it turns around and comes back the opposite direction. And what that enables you to do is it enables you to, if there's some sort of pin or something in our level wind roller assembly there, if that diamond screw turns in one direction, that roller assembly will go back and forth without having to reverse that screw. And so this diamond screw is driven by an attachment to the drum. Usually it involves some gears or some sprockets, because the diamond screw is going to turn faster than the drum, slower than the drum. What is it? No, it's slower than the drum. Yes, it's going to turn slower than the drum, because the drum has to turn several times to wind the tension member all the way on it. And then you usually have to put a clutch in there of some sort, because if anything goes wrong, if the roller assembly is not in exactly the right spot, you're gonna have to uncouple it somehow, move it to the right spot. It happens from time to time, even when everything's been going okay for a while. And a slug level line such as this, you might have to just adjust it a little bit now and again. So that's what your clutch is for in that case. So adding this degree of complexity, what additional problems do you think we're gonna have with our winch now? problems are most likely gonna be involved. Let's say, for example, it's not level winding anymore. Let's say that the drum is turning, but the level wind is not. What sort of problems might be involved? Yeah, the clutch isn't engaged. That's probably the low hanging fruit. Make sure your clutch is engaged. These diamond screws have to have a pretty good coating of lubrication on them. They have to be greased sometimes every 20 hours or so to make sure that they move smoothly. Otherwise they bind up pretty easily. So it's something that happens sometimes is you're cruising along and if this is a chain and sprocket, your chain breaks. Level wind gets bound up, the chain breaks, or the clutch slips, and now you're not level winding anymore. So those are things that you could check. Sometimes it's kind of hard to check the chain because it's usually in a nice guard or something, but you can
What about like a extra specially worn Acme screw? Kind of getting it.
Yeah, when these things get worn out, they end up getting a lot of play in them. And sometimes the roller assembly is not really where it needs to be at any given time to level wind the cable or wire rope very well. And that's one of the instances where you might find yourself, disengaging the screw and adjusting it a little bit until it starts rolling again. So there's some additional problems that could happen adding this degree of complexity. Just to, Walker, get that over. There we go. So here's a little. Where's focus? Oh, this is supposed to be a video. And I can't figure out how to make it work. Well, anyway, I had a video already for you to show you how that diamond screw work. Anyway, in the middle here, in the middle, the largest shaft in the middle is the diamond screw. It's going to turn in one direction, and you'll see that roller assembly sliding back and forth and back and forth. As you can see, there's something other than a diamond screw involved. There's these other ways that keep the roller assembly in the right position. The diamond screw just moves that whole assembly back and forth, but just for the sake of functional things, I didn't include that. So sorry, the animation didn't work. Okay. Adding another degree of complexity still. Well, let's go back. Okay, so why would we have a level? Why would this? Why would we need more complexity? The diamond screw. It's only going to work with one drum width. And you're going to turn it one direction. It's going to go a fixed distance back and forth. You can't have a level wind like this if you're going to change it. Like some winches have multiple drums. You have a tension member of one kind. You don't need that anymore. You take the drum off, you put on a different tension member. You can't have a diamond screw generally, or it might not work very well with the diamond screw. You can use multiple types of tension members on a single drum. With some success, what they do oftentimes is they'll have more than one set of gears that you can shift to a different gear. And then, if one tension member is twice as big as the other, you switch to a gear ratio that's twice as high as it was before, and now you're finding a bigger one. But you're pretty limited as to what sizes you might be able to wind on here. No, there we go, get that right. Okay, so what if we wanted to be able to wind any size, and by size I mean diameter, any size tension member onto our winch drum? It's a multi-purpose winch. Then we need another degree of complexity. The level wind is a whole different ball game here. We don't have a diamond screw anymore. We have an Acme screw. It looks very similar to this bolt. It's got a thread on it of a certain form, but it's basically kind of like a little bolt that spins. And then there's a feature in our roller assembly now that's basically a nut attached to our rollers and everything. Now we can't turn this in just one direction anymore, or else it's just gonna go to one end and stop. Now we have to be able to turn it in two different directions to make it go that way and that way. Now, the simplest way, not necessarily the best, but the simplest way to do this is what they call, with the following level one. And actually, we don't actually need any electronics for that necessarily. Sometimes they just have a smooth shaft and a sheave that can go anywhere on it, and it kind of half-assed slides one way or the other and works as a level line that way, but they don't look super awesome. Anyway, so we need its own gears and its own motor for that to turn that particular Acme screw. It can be the same power source as the winch or a separate one. It requires. It'll generally have a control system that operates independently of the control system for the drum. It just kind of does its own thing. And the way this works is you have these sensors down there, the little red boxes. And if the tension member on the drum is cruising along and it forms an angle with the level line, the sensor picks up or senses that the tension member is near the sensor. And in the control system, it makes the level line screw turn one way. If the line's going one way, it'll turn to make the level line catch up with the line. If it's going the other way, the level line will turn the opposite direction to catch up with the line. It just goes back and forth, making sure that the tension member is relatively straight. So this doesn't really require a complicated control system. Oftentimes on low-end winches and whatnot, it's just two switches. I'll show you an example here in a second. This type of level line does not work super well. It'll work okay if you have a nice round cable. Bigger the better. We have this kind of level line on our Dynacon tracking winch that we have in the winch pool. It doesn't work super awesome all the time with wire ropes, 3x19 wire ropes. It really doesn't work well with a line, a soft line. For one, sensing it can be a hassle. You can have like some of the wheels that ride along. I mean, you can't use a proximity sensor sensing a steel cable anymore at the line. You have to have something that's touching it to sense where the line is. At any rate, given this additional degree of complexity, let's see. What additional problems are we going to have? Well, what additional problems are we going to have with this one?
Like I said, playing the Acme screw, sensors are bad.
Yeah, playing the Acme screw, but in this case, if the tension member is tilted and they're slopping the Acme screw, it's still just gonna keep screwing until the tension member is straight again. Those, yeah, I was gonna say, those sensors are the only eyes and ears of this control system, whatever they may be. If the level line is not moving and the line is getting worse and worse and worse, then it's not sensing that the line's crooked. So the sensor would be the first thing I check. But obviously, there could be no power going to the Acme screw, making it not turn. You know, the controls can be fried if you use a voltmeter or something and check that when you press the switch or you put a piece of metal next to the proximity sensor, whatever it might be, you are in fact getting a signal, then maybe it's not the sensor anymore. Maybe it's a feature of control system. Yeah. So one problem we have with these Acme screws, with the diamond screw, the level line can only move so far. It's got a defined range, right? With these Acme screws,
I mean, what happens when you really jam a screw in a hole or something like that? It gets all stuck, right? You can't get it loose. When something goes wrong with these level lines and that roller assembly gets screwed all the way up against the winch frame or something, it's super hard to get that loose again. You gotta start disassembling everything. It's a pain, so adding another degree of complexity. Most winches that I've seen that have this sort of level one have these additional EOT end of travel sensors. It's just another proximity sensor of some sort, usually sensing the roller assembly. If the roller assembly gets too far one side or the other, it sends a signal to the control system to either stop altogether or don't go that way. So then, of course, an added degree of complexity is another degree of failure. If you find that the Acme screw is not moving back and forth as it should, one thing that you can check in addition to the sensors that are sensing where the tension member is, if they're fine, then one of the end of travel sensors, one or both could be bad. Any questions so far? So here's an example of that last one. This is a CMAC winch. And on the level wind, right here, on the level wind, you can see a proximity sensor and a proximity sensor. That's what's gonna move the level line back and forth in response to the angle on the cable. It won't work with the soft line because you can't sense the soft line. It has to be something metal, ferrous. And then you have these little switches. One's pointed that way, it just got a little nubbin sticking out, and one's pointed that way. And those are the end of travel sensors. Oftentimes they're mounted kind of over here and over here. And they're usually like proximity switches, but in this case, it's just a mechanical switch. When the level line gets too close to the winch frame, it just shuts off the power. So in this case, it should be pretty obvious if the end travel sensor is off, it's gonna crash. And I don't see how it can conceivably get pressed accidentally, but anyway, there's an example of that sort of winch. Now we're gonna add yet another degree of complexity. Once again, the following level line doesn't work well with all tension members. It doesn't work well with soft lines oftentimes. It doesn't always work well with 3x19 wire rope, although we have one winch that does work that way. So what if we want to wind 3x19 reliably all the time? Or what if we want to go back to our dream of level winding an arbitrary tension member, a tension member of any size? Well, then we need an additional degree of complexity. In this case, you see these purple sensors or pink sensors there and there. We're going to have one control system now that operates both the drum and the Acme screw. In order for this to work properly, what the control system needs to do, it needs to know how fast the drum is turning and in what direction. And then it's going to do the math to figure out how fast the screw should be turning to put the proper amount of power to the screw. But it can't just do that blindly. It has to know what actual speed the screw has. So it needs some sort of feedback, hence the sensor on the level wind. And it needs to know what position the level wind roller assembly is in. That sensor on the drum, the pink sensor on the drum on the bottom, that could be a number of different things. Sometimes it is two proximity sensors picking up some feature of the drum. Sometimes the drums have little stiffeners here and there. And it can pick up the number of drums, you know, features that are going by and count them and figure out how fast the drum is going. We need, if we're gonna use proximity sensors, I mean, 2. Because that gives us direction. If you have 2 right next to each other and it trips that one and that one in that order, then it knows it's going that direction. This one and this one, now we're going that direction. Now for the level line, we can't really use those proximity sensors anymore. Because we need what they call an encoder. Encoder is a little different. Inside an encoder, it basically has a proximity sensor. It'll be like a steel gear almost. And then with a little proximity sensor, and then it counts the number of teeth on the gear. But it's also got an electronics inside it that doesn't just count the number of blips to figure out speed. It actually memorizes what position it's in. You can turn off the power and turn it back on, and it knows still what position the level line's in. That information is useful for telling the control system various things, where the roller assembly is right now, but not only that, where's the drum? Where's the edge of the drum? Here and here, right? Usually, I mean, sometimes manufacturers make a control system for a single winch. More often than not, they make a control system for an arbitrary winch. And then there's some sort of routine where you jog the level line to one end and then save the position of the encoder, jog it to the other end, save the position, and then the computer knows where the edges of the drum are. Any questions so far? Okay. So with our most complex winch here, now we're controlling both the drum and the level line with the same control system. What sort of problems do you foresee there being with this additional degree of complexity? What additional problems?
Bad encoder.
Yeah, what's that look like?
Always forgets where it's at, or can't keep the home positions or the cheap position.
Yeah, sometimes you'll notice that your level line's kind of falling behind the cable. A lot of the encoders, like I said, it's kind of like a Ferris toothed wheel with a proximity sensor. That's kind of one thing that's going on inside there. That proximity sensor, you could usually adjust it in and out. Sometimes it gets a little too far away from that wheel and it starts missing teeth. So it loses the count. It's not really giving the computer a true position. So then the level line starts getting out of step with the wire rope or the cable on the drum. I can tell you, so you're operating a winch and also the level line's kind of like going this way and that way, and it doesn't seem to know where the hell it's supposed to go. It's generally the encoder. Yeah, but it could also be that the control system doesn't know how fast the drum is rotating either. It could be, we could be having problems with either of those 2 sensors telling the control system what the state of the drum is and where the tension or where the level line, the roller assembly should be. So with our end of travel sensors, with our following level line, on the winches that I've dealt with anyway, on the following level line, generally speaking, if you trip either of them, the level line doesn't work anymore. But I know for a fact that on this type of level line, generally speaking, you might come across the behavior where the level line doesn't mind going one direction, but as soon as it needs to go another direction, it won't do it. So generally speaking, what that means is one of your inner travel sensors is not working properly. It's failed to the safe side. It thinks that the level line assembly is right up against it. So the control system doesn't mind moving you away from it, but it won't let you go closer to it. So yeah, if it only moves one way and not the other, then that's often the problem. Once again, with level lines in general, if the level line just doesn't seem like it wants to keep up with the tension for, it's not going. It's often just you need to lure people. That acne screw gets dried out and then it doesn't flow anymore. So. Yeah. So are we building, have we built a pretty complete picture of how an arbitrary winch works? Is everybody feeling confident? Have any questions? Or take your silence to mean that I'm a masterful instructor? Okay, so this is not necessary for the winch per se, the winch operation, but a couple more things that we often throw into a winch or a handling system sometimes is sometimes we want to know what the tension on our line is. If we're going to do that, the most common way to do that is to wrap the tension member around a sheave. Now, this could be a sheave that's a feature of the winch. It could be a part of level wind or some other place on the winch. Or like I said, it can be somewhere else. Sometimes we have hanging blocks on the A-frame that have a load cell in it, right? So how this works is we have yet another sensor. It's a strain gauge that's embedded inside a pin that goes through the middle of the sheave, and then the sheave rotates around this pin. And then if you supply the electrical circuit in the load pin with some current, as the load pin is loaded by your bending tension member, or your tension member wrapping around there and becoming loaded, it varies the resistance in that circuit inside the load cell. So it creates a varying voltage. And then the meter uses basically a scalar, some proportionality constant to translate that into a tension. So generally speaking, we have to tell the meter, we have to program the meter in some way, right? And the way we do that is we generally put one load on our line. And then we tell the meter how much that load is and to save whatever voltage it's getting. And then we put a higher load or a second load anyway on that line. And once again, we tell the meter how much weight that was. And it records, the electrical signal it gets. And that gives it a scalar, a proportionality constant that they can use to tell you how much tension you've got. I can tell you one problem that we often have with our meters that we put on our winches is that the 2-point or the linear model, the proportionality model, is not generally accurate. These load pins create a voltage versus load curve that starts out one direction, kind of curves up and then gets steeper oftentimes. Right, so when you're giving it a 2 points, if those 2 points are up here, where it's straight, then it's accurate. If your 2 points are kind of in the roundy part, then it's gonna be all messed up, between your points. Does that matter? That depends. What you really want to do is you want to make sure that it is accurate at your greatest tension you ever want to see on the switch, right? Your safe working tension, right? The way you do that is you make sure that the second point that you program in the meter is a load that's equal to safe working tension or pretty darn close, and then it'll be pretty accurate at that load. Okay. Any questions before I move on? Yes.
So if it's not always linear, is there a way to do it with like 3 points or 4 points? Of
Sure.
different.
Sure,
weights?
it's possible to program a curve. I don't know, do the,
Yes, you can, to improve the accuracy of the 2-point calibration, the minimum is 2 points to calibrate a potential. You can do up to 25 points if you wanted to really be conscious of the accuracy. You know, 3 points should probably get you good, probably. The displays on that we provide, you can do up to 25 points.
yes. Yeah, rugged control makes super fancy meters, so, but they can be very accurate.
I'd say 90% of our customers do a 2-point walk away from.
That's what we do oftentimes. So. This is just for anybody that doesn't know what these load pins look like. Like I said, it's just basically a shaft. They do some machining, but it's got strain gauges in the middle of it that they cast into there, and then it's got a little electrical connection, but that's it. Pretty simple, but you can, now that you know what this looks like, you can spot it on a winch. You know where the load cell is, or if it's on a sheave or what have you. So, also not necessary for operating the winch, but often information we want to know. What if we want to know scope, or how much we've paid out or hauled in? Then we need another sensor. This generally takes the form of, and that is this guy, right? And then these little roundy bits. So the sensor is often just a proximity sensor. And there may be a feature of the sheave, like it might have holes cut in it, so there's a piece of metal going by periodically that it can count how many times that happens, or but if it's like a plastic sheave or something, or there's no thing for it to really pick up, you can glue like little metal circles on it periodically or something like that. But it's basically just counting how many times those little metal bits on the load pin, or those features, on the sheave go by. That's how it figures out. In the meter, you have to tell it how many signals, or how many blips, or how many senses in one rotation, and you have to tell it, what that means in terms of feet. What's the circumference of your sheave, the root of your sheave, or the sheave pitch anyway, center of the caving. And with that information, it can tell you, it can count and tell you how much you put out or pulled in. So, what are some problems that we're gonna have with our scope? Let's say you paid out a whole bunch of line and it doesn't think that we paid out a whole bunch of line. You know it's more than 500 meters, but it's saying 100 meters.
Sensors bad, or the metal counting, it's come off.
Yeah, it's not counting for some reason. Oftentimes those proximity sensors take the form of just a cylinder with threads all over it, that we can like screw it closer or farther away to the thing that's sensing. Sometimes that needs adjustment, sometimes your sensor's busted. But one thing a lot of people don't realize, and I've seen it happen before, is I've noticed the line's paying out and the sheath's not turning. Like if it's a slippery line, like a piece of Dyneema or something like that, if it's at low tension or something like that. If it's a big sheave made to hold tens of thousands of pounds and you're putting 200 pounds on it, it's probably not gonna turn that sheave. And then you're not gonna get a scope anymore. And I honestly, I don't know what to tell you. If that's happening, there's not a whole heck of a lot you can do. Keep an eye on, how much line you have on your drums.
Way too much grease on the spots, the sensor won't pick it up.
There you go. So, and this is what one of those sheaves might look like. It's got a load pin in the middle. I learned this morning laser pointers don't work on these things. It's got your load pin in the middle here with this little wires coming out. This has 2 wires coming out of it. That's because it's a 2-axis load pin. That means it's sensing force in 2 different directions, and what that enables you to do is you can calibrate it with a certain amount of wrap on the sheave. And then if you tell it what the angle of wrap is or whatever, it can be fairly accurate at any event. So anyway, that's a 2-axis load gun right there, and then we have our proximity sensors right there, boop, boop. In this case, it's just picking up the metal pattern, these teeth that they machined into the sheave here. It's just counting teeth. That's what that looks like. Could look like anyway. So, do we have a fairly good mental picture of how arbitrary winch works in various degrees of complexity? Okay, so now we have got a good mental picture. I think we're most of the way there to be able to troubleshoot a winch with a little bit more tools. What are the other tools we have at our disposal to troubleshoot things? A manual. I wish that wasn't right there from the manual, but anyway, our manuals, right? Now, most of these additional tools we have at our disposal, I want you to pay attention to the fact that these are all things you could do before you go on your cruise and use this winch, right? If you do your homework, which I understand is time consuming, but if you do your homework before you use your winch, then once again, you have a really good idea of what might be going wrong, where to find out, how to troubleshoot it. But anyway, in our manuals, we might find photos. Seems silly, but they could be really useful. Maybe you've never seen, maybe it's coming from the winch pool, maybe you've never seen it before. You can sit there and look at some of the photos and be like, oh, there's a level wind sheave with a load pin and 2 proximity sensors. You know how those work, and when things that go wrong with them, it's hydraulic winch. I can tell by looking at something or what have you. Drawings, there's often drawings that you could do the same thing. You might be able to identify certain features of the winch and know what you're dealing with. Written descriptions of, what the winch, how is it powered? How does it operate? Operating procedure. Now, operating procedures are nice to read, because so you know how to run the thing. But also because they typically involve, hey, don't do this or this will happen. So then when that actually happens, you might think, oh shit, did I do that thing? And they're also very handy. If you operate it properly, you're less likely to have a problem, period. It includes these warnings I mentioned. Troubleshooting guides. Hopefully, that has some sort of troubleshooting guide in it. And
placards.
Yeah, placards. There's stuff in there. Don't do this or do that, or take the shackles off the winch that you lifted on before you run winch, or else you're gonna break the winch. We've had that happen before. Yeah, troubleshooting is really handy to flip through different kinds. A list of this isn't happening, or this thing is not working, possible causes, how to remedy that. So if you read through this and you have it in the back of your mind, when one of those things happen, then you might remember what to do. But more than anything, if you just know where that guide is in the manual and you can access it, then that's going to save you a lot of time. And here's an example of one vendor's. Well, this class is specifically about hobble winches. Their manuals have very good troubleshooting guides. Now this troubleshooting guide in their manual is in the alarms section. Because one of the beauties of having fancy pants, computer controlled winch and whatnot is just like your new cars and stuff, there's an alarm for everything, right? This sensor's bad, that sensor's bad, it tells you oftentimes. So here's an alarm, maintenance required. What does that mean? The winch was operated with 2. So anyway, this alarm, this is a very good troubleshooting alarm. unless the level one stops moving. It's just a reminder to grease the level line and some other things. But here's a good one right here, high temperature warning. We had somebody call us about that just the other day. The winch is overheating, why? It was operated too long. It was operated when it's too hot outside. The starter panel oil cooler switch is off. That's an important one. On this particular winch, you can tool, it's an air-cooled winch. It's a hydraulic winch with an air-cooled, with like a radiator on it. And the fan comes on and off automatically, but you do have to turn it on. So that's important to know. Oil temperature, anyway, there's all these various things, causes, effects. Winch alarm flashes. I think they already probably figured that out. The light, the remote alarm light blinks on top, the red beacon light flashes anyway. And then most importantly, corrective actions. Look at this. Yeah, if you're operating too much, give it some time to cool down. Reset your warning, verify the wiring is per electrical schematics, and that's referring specifically to the cooling fan and the related stuff. Ensure this done. Yeah, so anyway, if you run through this and stuff, there's some really good possibilities right there for correcting that issue. What else? Yep.
What about kind of like that one? That how about they were using on that trace metal one I was telling you about, it got really warm. As
Yeah.
well.
Yeah, I got a phone
there,
call about that.
yeah, I think probably Craig might have called you or something. It wasn't like the motors were, you could put your hand on there, but if you stuck your fingers down the heat sinks, they were, it was hot.
Yeah.
Is there a place in the BFD or something like that that you can, that it has a switch? I mean, I looked through all this on the manual too, and it didn't have anything about an oil cooler switch. Obviously it had a cooler, I can see the radiator thing there, but
I don't know,
any kind of switch or
but if there's a sensor in the motor, oftentimes there's a type of switch, I guess you can call it, inside an electric motor. If you're getting too much current through there too long, basically it just melts. And then the motor doesn't have power to it anymore. But I mean, if there's a sensor in the motor, there are motors with sensors like that in it. Then for that particular winch, I would imagine, then there's alarm, and then there's in the troubleshooting guide, there's something in there. But in that particular case, yeah, we looked information up for that motor, and the manufacturer said during normal operation, caution, they may be 120 degrees.
Right,
So they get hot, period. Yeah.
Yeah, I figured that it, like I said, most of the standard rules, like you can hold your hand on it, good.
Yeah. Yeah, but you know, if you're with a new piece of equipment or in a new scenario, sometimes things happen, you're like, is this okay? And that's great. Great to ask questions and not assume everything's cool, and then something goes south. Okay, so we have our troubleshooting guides, we have our manuals and our troubleshooting guides in the manuals and other information in the manuals. That's an important tool that you can take a look at before you even use the winch, before you've even seen the winch. Other tools at your disposal, sometimes these are in the manual, sometimes they're not. Diagrams of all sorts. Most winches are gonna come with some sort of electrical diagram, hydraulic diagram, if it's a hydraulic winch. You can glean a lot of information out of that, you know, build a model in your head. What am I dealing with here? What sort of problems might I have? Electrical diagrams and hydraulic diagrams are all over the place. Some of them really suck. And some of them are really awesome, but nonetheless, they have important information or good information you can glean from them. Here's a electrical diagram from one piece of equipment that we've got. It's the terrible, well, this page isn't. Anyway, it's a functional diagram. If you go in here, you can see like we have this, oh, there's an overload state, a light that blinks on or something, overload, fault, time remain, fault, right? There's some voltage that comes in here. There's a whole string of switches. If anything is open, you're good. It's not gonna create a fault condition. If any of these switches open up, the winch is gonna have a fault. So in a way, this is good information, right? You, well, it doesn't show it here necessarily, but in this case, the fault condition just turns off the winch, right? So if the winch just turns off, well, these are all good things, whatever they are, it's checked, right? This is a 70 degrees, I know just because I know this winch, but this is 70 degrees Celsius, hydraulic oil temperature. This low is a low level switch in the hydraulic sump, et cetera, et cetera. The winch just shuts off all of a sudden. Here's all the stuff that you can check. But this diagram is lame in one way. This is not how anything is wired together at all. Right? We have, you see, I have these random numbers, 17, 15, 14. These are wire number 13, right? But if you open up this winch, there's 50 wire number 13s. So it's enough information for you to know what sort of components you might check. And they are, this manufacturer does, you know, there's 4K6, 4K4, these switches and whatnot, they are numbered. So you can go there and start checking voltages across the switches and whatnot, but so you can diagnose a fault with a component, but if the problem is a connection from one thing to the other, forget it. This isn't going to help you a whole lot. Now let me back up a little bit. I mentioned checking voltages and all that stuff. I want to make this very clear right now. If you don't think you have any business dealing, you know, poking around a winch's power panel and stuff, you probably don't. I don't mean that anybody should actually be checking circuits themselves if they're not comfortable with it. But you still, it behooves you to figure this out because there'll be an electrician on the ship, hopefully. But that person has not taken the time likely to figure out this winch and what might go wrong. But it's very helpful if you're there, like, I think it's 4K6 or whatever, and check out the terminals, this and that. Then they can start, you know, doing it for you and you're leading them and you can get it done. Otherwise, you know, this person that hasn't even seen this winch before has to like outsmart it from square one, which takes forever. Here's another, so since this is specifically a course or mainly a course on Hubble winches, here's a Hubble wiring diagram. This is a different style of diagram altogether. This is exactly how it's wired together. And Marky's diagrams are this way too. Marky and Allied, your diagrams are great as well. But you'll see these numbers, right? It's kind of has some functional stuff in here. Here's our oil cooler motor that turns the fan that cools the oil in our radiator. There's wires coming off it and there's numbers on the wires. Every single wire in this winch is numbered. So let's say back to the winch is overheating scenario, right? We can open up the winch power panel and say, well, is there power going to the motor? Why is it not turning, right? And you can, this is the contactor K3040. It's also, you know, plainly labeled inside the box. You can look for K3040 and check voltage or have the electrician check voltage between this number and this number wire and determine, is this contactor closed? It should be closed if there's power going into there. So if there's no voltage between it, the switch is closed. You know, if there's voltage, in this case 480, well, it won't be 480. Anyway, if there's a higher voltage across this, then the contactor is open. That's why the winches or the fan motor is not going on. And then you can go figure out, well, why is this contactor open? Or you find out that, well, there's no voltage here either. Why is that? Fuses, all numbered inside. What else? Let's see. Oh yeah, so we have our contactor K3040, but then what turns that on and off? I don't know. But if you start flipping the pages, you would see in another part of the diagrams. Here's kind of hard to see. here is K3040, that's the contactor. And here's the current going into that contactor and the things that have to happen for that current to make it. There's a oil cooler switch. That's the one that you have to turn on. There's a temperature switch. And once again, all these wires are numbered. You can go inside that winch or have the electrician measure the voltages between terminal 31, 41, and 342. Is there no voltage across that? Is there voltage across that? To try to troubleshoot the problem. Any questions so far? Yes.
Sorry, this isn't fully about this point of troubleshooting, but could you backtrack to the last picture of your winch?
Yep, make believe winch. That one?
Yeah.
Yep.
So, I'm not winches that have like auto rendering.
Yep.
Is that gonna be with the load pin and like just kind of the level line, or is there other sensor like backtracking to consider when you're doing auto?
So. As far as components.
Yeah.
Function,
Or like, oh.
like this is as complicated as it's kind of gonna get.
Yeah.
But there could be all kinds of stuff going on inside this control system, right? So you mentioned auto render or render and recover. Those are things that could be programmed into the control system. So in order to have auto render or render and recover, you have to know how much tension you got usually, because usually like you set that. And for those of you that don't know, auto render is when if there's too much tension, the winch just pays out. Right, and that reduces the tension in the line. So in order to have auto render, obviously, you have to know tension. Give me a second here. So the control system is going to, doesn't always sense tension so much. Sometimes it just senses load for some scenarios. But for auto render, do the marquee systems actually take? They actually do take to consider the signal from the load pin to determine what the tension is, correct?
That's correct. So
Yeah.
you've got a control feedback coming from your load pit.
Right.
It goes into the control center. And what happens is you've got a potentiometer, so you can dial up or down what that render point is, or recovery point. So what'll happen is when you get that load pin signal, it's electrical signal, it'll go in there and then it'll say, okay, it's too hot.
Right.
So render, it doesn't physically pay out. It doesn't turn the drum. It reduces the amount of torque on the motor so that it still controls the tension on the line, but it lowers the tension as it pays out.
Mm.
And then when it lowers beyond that set point again, then it'll stop paying out. And you can either set it or control it to recover back to that original point, in which case now you've got a reading on the scope sensors. So that's tracked inside of a memory. So it'll go back to that, or it'll just render and then sit there again. So there's a lot of ways to do it, but it's all computerized. It's a program logic controller, and it's firmware that's been developed for that purpose.
So yeah, the control system could reduce the load on the line in different kinds of ways. One way that nobody uses, but it's possible. Somebody proposed it one time, and that's how I knew I wasn't gonna go with that manufacturer. Is if you know how much torque is on the drum, and you know where the tension member is on the drum, the radius, then you could deduce the tension that way. But the problem with that is you have to know how much line you have on at all times. So if you cut the line and you don't program it in the computer that now the line's shorter or something, it'll never know what the actual, radius is. Another way that you can sense load in different situations and use that in the control system is, for example, if you have if you lift something and then you stop. And then you want to continue, but you don't want it to drop the deck and then go on. You want it to smoothly lift it from where it was stopped before.
Yes.
You can also sense the load. You can tell the computer to make note of how much load is on, we have right now, and then, you know, give me enough current or hydraulic pressure or whatever in my motor next time, before you release the brake so that it lifts it without dropping it. And that's typically in an electrical system, that's not typically done with the load pin. It records how much current basically is going to the motor, it remembers that, and then sends the same amount of current next time before it releases the brake. Yep.
This guy mentioned I got to do sometimes use drive torque, like from electric winch.
Uh-huh.
The cutting cable tends not to be an issue, you just back to tracking how much cable's on the drum. So if you data years, you kind of, you know, it knows you data at 100 meters and knows current fit radius.
Oh, I see.
They can typically get like within 2 to 5% accuracy attention.
Okay.
Fit radius.
Okay. So, any more questions on this diagram or? Yeah.
Diagram, that
Yeah.
I don't think is super related.
Mhm.
So one thing about one of my winches that I've had to replace that I don't think I see on the diagram, or else I just don't know where on the diagram
Right.
this is a 3-phase monitor.
Okay,
Where does that fit into this?
well, that would actually be yet another sensor.
Right.
Yeah, so, I'm gonna bring up, a component. You know, there's something in a lot of winches called a safety relay. And it can take, you know, input for various kinds of sensors and stuff. And, either turn on an electrical signal or turn it off. Well, what was your component? The phase monitor? Yeah, so in that case, the phase monitor, if the phase is right, then it sends a signal sometimes to the CPU. Sometimes it sends it to our safety relay that it's okay to power up the winch. Yeah, but yeah, that's just another sensor basically. Thanks for bringing that up. Any other questions? Okay. Is it time?
Yeah.
Wow.
Yeah.
Okay, sorry guys. Anything else important here? No. That's a picture of one of our winches. I was just proving that things are actually numbered. That yellow thing right there, that's a safety relay. The 12-inch relays. Right in the middle of the picture, there's your 3-phase monitor right there. But anyway, I hope it was entertaining or educational or something. All right. Well, that was a longer talk than this.
It's okay. Obviously, there's.
Hard to tell the first time around.
I'm trying to crack.
Well, I didn't try to practice, I got done.
No, you. Let me do it.
Now also got coded for. You guys don't have your.
For Gabe at UAF?
I am me.
Talk about it, because we got people online.
Talk to the owl.
Yeah, just, you can stand there, but it's good. Just talk louder.
I'm Gabe. Fairbanks, RVTEC. I think we all know each other.
Yeah, you don't need to introduce
Alright.
yourself.
Here's the biggest challenges for the ship have been trying to figure out how to go to Antarctica, I think, because we're totally changing gears and crossing the equator for the second time in the ship's life, the first time being last year by about just enough to the line crossing ceremony. It's just and then there's the elephant in the room that I'm not gonna bother mentioning, but
Tim's not here.
Tim's not here.
Yeah.
It's a big miss for the meeting.
Yeah. Other than that, I don't have a baseline to compare against, so everything's on fire as it should be.
It's enough for that was really on fire.
For the year.
Yeah.
Julian, also with Sekuliak. I think from the technical perspective, one of the bigger challenges we're facing is the ship and our OT systems approaching 10 years old. Things starting to fail and not necessarily having the funds to replace systems that are failing.
Sarah Fuller. We, couple of different types of challenges. Obviously funding and what are we doing? And with that, new relationships with O&R, not non-Spirit related. And trying to have people that are used to gray holes kind of understand that we're not like that, we're not survey ships, so we just don't have the staffing to just turn on the SVP 29 with a bajillion variables and just have it collect data on its own. And out of the sub-bottom stuff, the, calibration standards and differing opinions on those and quantitative versus non-quantitative calibration methods. So navigating those relationships while also trying to put up the gentle boundaries lightly. And then, attrition, which just happens. So we're down, as of December, we'll be down 3 tests. We only have 6 between our 2 ships. So hence why there are job postings. And the last one is trying to build a new Met Tower for Atlantis. We have the funds for it. And we've been through exhaustive design with Boston and have gone full circle back to replacing it in kind because of stability concerns. Our Met Tower is basically a radio tower that is hinged and lowers. So that's basically what we're back at, which is disappointing because we wanted like a Sequoia style tower or like a ride style. That's climbable and a little bit safer, but no luck. So back to square one.
Lee out with scripts, challenges kind of beginning this year, there's some challenges with Ravel, coming out of the shipyard. But the good news story is once we did get those problems resolved, the ship's been working well. Sprout, aging ship, it's getting, it's kind of stringing things along as long as keeping things working, that's good, so that's gonna be a continued challenge. We'll figure out exactly how to go from that vessel. Sally Wright has an aging OT system as well, so that's things we're certainly concerned about. And then I know there's funding issues, but I have had to eliminate positions, I have had to conduct layoffs. So that's been, we're gonna feel that operational pain more as we go into next year, but I know there's a lot of uncertainty. So that's been a challenge here in the second half of this year.
Rory, Bars, in Bermuda, we've had a busy year, we, started the year off in shipyards, the giant headers and shipyard, but, pretty successful, we're in pretty good shape coming out of it, we just want to take a couple of projects down the road, but we're very happy with what we're trying to. Honestly, successful from that, and engineering had a few issues with that for a while, but we're after that, very good. But yeah, fortunate with quite a few, funded days this year, and so the time series are kind of a ball and chain sometimes, but right now it's kind of a more positive for us. And staff retention, of course, it's an issue for us too, but hired someone there to, fill that vacancy that we had. Yeah. Little issues here and there, but it's getting, secure.
Hello, everyone, Vishal from University. I think the biggest challenge in front of us is to find out that the government shutdown was lifted earlier. So that our grant, which is going to effect from next year, becomes a reality. Otherwise, the steps are difficult that.
Craig from Hawaii, it's no longer the elephant in the room, because I think as everyone said, I mean, it's just screws. Everything from what you were talking about, I can't replace something if I don't have any to replace it with, and I'm a tenant, I might not be able to actually pay somebody. And then going to Sarah's point, well, I don't wanna hire somebody if I can't pay them a month, because that's wrong, but then I can't keep anybody because I can't give them a schedule for next year because we don't have a schedule. We're not allowed to have a schedule past the first quarter, so I don't think it's an elephant anymore, in my opinion, it's just absolutely enormous. So.
Hey everyone, Vishal Nagini, I'm also on the top staff. I'm giving essential form that was for the fee and, my biggest challenge has been, probably chasing some of you to get, a cylinder response plan for your shift. So I'll continue to do that until unless all of you have, at least, one essential response plan for every shift of your team. So, yeah.
Karen Stocks from R, staffing has been a challenge, we had a couple of positions, I just couple rounds, we did. Finding out about 2 weeks ago, where our positions filled. You're working hard on a big smart infrastructure update, replacing the aging project phone hardware with sort of scalable data center kinds of things, and it's going well, but we've got a the hardware we have will fail at some point, so we have a firm deadline there. Understanding how data volumes are growing and our storage costs associated with that, are really affordable to take backup, service, they triple their maintenance costs on us, so. Wrestling with that, and to predict how much aid wall are going to be, and once their leaves come on. And then the kind of a background, is just understanding how AI is going to change what we do over the coming years. Smooth and quickly and I understand it.
Hi, Kevin, we had a lot of good success this year. There's a lot of challenges, of course. We have moved into a new facility, but the university, I know RVTEC, we find a big, beautiful kind of marine center with Marseille and other things. And then obviously 2025 did. Everything kind of got shelved, but hopefully that comes back and some promises. We had multiple hiring lines, but let's hold off on hiring, and then we only had one, but hopefully we can resolve that in the coming years. I think that was budgeted. Biggest concerns is I don't have a budget starting in January. I'm still on supplements to go up looking at what projected. So I kind of need Tim, as we all do, to come in and fix them to make sure I have salary starting January for tests. And then of course, I met with a dozen PIs that at some point basically told they might have a cruise manager, they may not. So I got all these plans and lists and to-dos and the money or idea of when I need that. Same kind of issue. Well,
Sounds like another plus one.
yeah.
Yeah.
Mike Simpson, RVTEC, as my colleague, foreshadowed, the biggest issue right now is the contract with OmniSoft for the, RVTEC team. And the cybersecurity services runs out at the end of January 2020. We were encouraged by some members of the community as well as NSF, specifically Laura and Tim, to switch from a contract to form a tech services project and have it directly funded. We have put in the proposal for that, just as the government shut down. Tim knows about it, that it was gonna be submitted and has a plan, he said, for getting it reviewed. So, if it is, as it is written, approved and awarded, we'll be continuing all of the services that we have, over the past 3+ years, plus some additional, good services. I don't want to detail too much about it because I don't know if, the plan is going to, change, because of funding or the like. So, I'm being optimistic. You might have noticed that I'm using the term ARF-SEC team a lot more than Omnitalk because that's what we're going to move to.
Jules Summon University of Hawaii UHS group. We have not had problems with, not big problems with our attrition this year. I think the two big things are that our outfit, just like with the multi advisory committee, they're funded by multiple outfits. So we've got 3 legs to our stool. We have National Science Foundation, we all know how that's going. We have NOAA, which we got our money for the last year. It did come through. And then we have to have another contract probably once per hour. That's good. We don't lose that. The other school is all either international research institutions or philanthropic organizations. Some of them will do quote invoice. Most of them on a contract, and the University of Hawaii Grants and Contracts Department is so bad that it can take them 3 or 4 months to review a contract. So we only got our Falcor Schmidt contract signed about 2 weeks ago for all of the work for this year. So we did all of the work. It's monitoring on a daily basis and processing on a monthly basis. We did all of that. I hope we don't get audited because Williams and money looks like a graphic equalizer. And then the other challenge is that, I don't know if you remember that, the old song from Sergeant Pepper. I get older and losing my hair many years. And now you 64. Well, we all hit different, issues at different points. I turned 64 this year. I'm like, oh, shit. And then all of a sudden, it's like Medicare next year and I have to have I gotta have a successor. Do I have a plan? No, I don't, there's no funding to hire somebody to bring up. The only plan I have is to cut my salary by 50% to support somebody. And so the first challenge is to find somebody, and the second challenge is to train them up and help them pay.
You went the Hui way, you retire and then you come back for the next like 10 years. Without benefits.
I plan to retire and work for free at a lesser level, but there still has to be somebody there carrying the torch. So I'm not sure how that's all gonna look like.
Eric Early, URI, are, obviously being ordered to divest our ship was expected, but it was surprising, like, we got that. With no notice whatsoever, and that's been pretty typical over the last 5 years. So just been kind of operating off of rumors, and NSF didn't want to commit one way or the other. The RCRB project is infuriating, at least, just their the lack of ability to even have a schedule with, what else? I mean, we're divesting the Inver now, which is kind of new and interesting, but it felt that the time stuff like not productive. So, but we're looking forward to distributing our equipment, filling in your budgets. Helping out there. Tech exchange availability, like we have people that want to go to see, myself included. I'd like to get out of this stuff to fully active your closest analog to the RCRB and get some better perspective of how you guys do things. That's it.
Hi, everyone. Brandon, that's you. We've had the sort of continued challenge of operating and scheduling a ship of our own. Actually, this month is a 4-year mark now here in Cairo, so for a long time. And we've somehow managed to maintain a pretty large group despite that, so that's nice. Staffing hasn't really been an issue, and keeping folks engaged and motivated and happy enough to stick around, while we wait during this transition. So, yeah, similar challenges with the service scheduling. Trying to create opportunities at the university with projects while also balancing opportunistic sailing through tech exchange has been tough. But we really appreciate any sailing time that we've had, so far. So, we're getting close to when our funding will shift fully to our survey. We're right now 6 months away. So we have enough projects to carry us to that point, but if it might be in trouble. So, and then also stepping into this role a few months ago has been fun. So, yeah, I'll stop there. Thank you.
Don Kuchera, University of Miami, Walter Smith. Not too much on the tech side. We've had our one tech for 20-something years, but he's getting close to retirement, so that's a scary part. Crew wise, more ship offs. We had to go through a new captain and a mate. So getting them spun up on deploying instruments, they didn't really have research festival experience, but they've worked out well. Also had a new dean come through, so he's in-house, so hopefully that's a good sign and seems to be hands-on. So those are challenging things for this year. And then next year is obviously funding. Everybody's asking me for a schedule for next year, but if no one knows if they've been funded or not, I can't come on the schedule with MFPs, you know, setting our daily rate and stuff. So that's the challenging part. And then obviously, before you can attest to this, hurricanes and stuff like that, that was a big challenge in this year. Melissa just went through, I don't know if you pay attention, to Cat 5 going through Jamaica. It was unreal, it was 185-mile-an-hour winds. That's 30 miles an hour over Cat 5. And Cat 5 is the highest, so. Global warming, you know, people want to talk about it, but yeah, I'll just been there.
And then, yeah, I'm sitting in for Joe at MumCon. Our biggest challenge has been with the new Pelican build on the way. We're trying to upgrade the current Pelican to be more standard for the fleet so that we can roll over and make sure that the new Pelican is like up to standards. That means that there's been a lot of upgrades within our cyber infrastructure and our network. And then moving on to more of the hardware around the vessel. So that's been a little bit of a struggle, like figuring out what is standard within the fleet and what needs upgraded. And then the next thing, which was like a huge plus, and it turned into kind of a problem, was we just moved to our home dock, which is better for everybody. It's better for the boat because we're actually sitting in water right now instead of sitting in mud. So we were able to have like a diver come down and cut everything out of our propellers. But it also means that we had to completely reinstall like shore power and shore water. So that was several days of just running off the generator, figuring out how to make the new dock work for the crew and for the boat. So that's, we got through.
Did you work with Circuit? The Circuit?
Just get connected.
Okay, good.
Yeah.
Thank you very much. For everything.
And we'll go online. If folks are willing to share, we have the Eric Trotto in the wire pool.
Biggest challenges this year were just getting wire. They continue to have long lead times. Sometimes the wire we receive isn't up to the quality that we're looking for. We had a problem with 1/4-inch wire, the metallic with it. And then another problem we face this year is there's continue to be electrical problems with cables, but that's just a continuing deal with cables. And that's about it.
And then I'm trying to see, Doug Rickett.
Yeah, I guess our primary problem is just we are working a little bit later into the year. And so right now it's just weather. They're out on the lakes and the lakes are a little bit rough. November is not great on the Great Lakes.
And Jesus.
Everybody, sorry I couldn't make it this year, at least the beginning of the year. Most of the time I try to go for a couple days. But we've got a busy schedule coming up here towards the end of the year where I need to do some more traveling. But things are going well on the line set. The biggest challenge, obviously, is the age of equipment, the uncertainty of continuing operations, um, and getting to know all of the new equipment or the new types of equipment that we didn't have that now we're doing. So training, spares, calibrations, all that good stuff that everybody has always dealt with, but we have not. So got to learn it more this year. Scavenging around for any surplus equipment, on lab spaces or CTDs or any of that stuff that we normally wouldn't. So I'm interested in any of your old gear that we may be able to use, because even though you think you don't need it, somebody else might. So appreciate any insight on any of that sort of equipment. But yeah, hopefully we've got a schedule kind of ready to publish as soon as we get approval on shipyard, and we'll have a good 2026 with more seismic work. So we're happy about that.
Great. All right, so that's sort of a round robin that we normally do at the end, but since we didn't have any specific topics, but several of you came to me with some things that you had on your mind. And the first one I just wanted to bring up was Rory had sent me some photos of Niskins, and so I was gonna put them or share them on the screen, and kind of let you share your. Hopefully. There we go.
Yeah, so this is just a bit of a saga we've had with ocean test equipment. And I'll share with the reminders just so that people are aware. So we designed our own CTD, got that funded and got delivery of these new samplers in early 2024. And the first thing we noticed is you can see that top left over there, where John switched to two-piece, instead of a single piece, it was made up of two pieces and glued. Sometime during COVID, he said, basically you're kind of getting shipped and breaking the end caps. So he said, okay, I'll replace all of those. So he replaced them and we got them back and they're great. And we started cruising and using them, getting a really high rate of misfires. And, the techs on board, as you can imagine, we do a lot of CTDs for bats and so on. So it's a lot of what we do. When they're chasing, what's causing these misfires, changing lanyards, swapping springs, all the usual, rigmarole. And we weren't, eliminating these misfires. So we're talking to John throughout the whole process. He suggested some changes to the way you're rigged, and we rolled out those changes, and we're still getting misfires. So, we're just scratching our heads and just like, what can we do here? So I was like, right, why don't we put some of the end caps from our old samplers on, and then, the misfire rate went to almost zero. So it was, the end caps were the problem. So if you kind of scroll down, it's kind of hard to see, I'll just email it around to you guys, but there's a flange around the kind of curved section of the mating surface, and he's really changed the diameter of that flange. So you're getting over rotation on the composure. So, we did a lot of samples of our CTDs in deep water, 4,000 meters. It's a lot of time.
Yeah.
And talking to John, it's like talking to a brick wall. Or, you dealt with this. I'm ready to, put them on the bike journey. And he said, okay, it's our fault. We'll replace them. Like he did with a two-part, but then with these, he said, okay, it's something to do with the diameter. I'll replace them, and then he rolls back. And I argue with him, okay, I'll replace them, and he rolls back. So yeah, I buy, 48 UN plus for $1,000. Trying to get across and being managed to ship, trying to be lost, and frustration with the text, it's just the real thing, yes. And we have Morgan's trace metal rosette on board right now. And yeah, they're getting like a 15 to 20% misfire rate because they have a smooth pickup.
Oh, nice.
Yeah. So, yeah, I was kind of giving John, you know, just been going on for a long time, but I want to give him a chance to put it right. So, for sure, so. But yeah, I'll send the photos around, maybe you can share it to your team. And take a look at what- So I guess at some point, well, you change the two piece, so if you have those, you tell them, you should replace them, but if you have these, and you're getting high this fire rate, it's only gonna, you know, verify our theory that it's the, it's that the width of that flange.
Wow. That's crazy.
This is Joe again.
No, ocean test equipment. Yeah, he was also running for Romanian presidency, and he was like totally anxious to deal with this. Yeah, it sounds like a joke, but it's not.
Maybe you could go to general OTA?
Well, yeah, like, if I could roll back the clock, I really would, but we had OT samplers, so we thought for theirs and, you know, we got more, but yeah, if I could roll back the clock, I absolutely would.
We ordered 10 representatives from OT this year, had quality control, because we had to send them back. They use external spraying. All the glued on parts were glued on their own spot, they don't care, so. We sent them back, we had to tell them exactly where they're now. No problem, man.
Yeah.
We do the Sharpie working.
Yeah, yeah, and you know, at one point he was like, well, I'll come to the shipyard up in Jacksonville, I'll take all the bottles away, he turned up his Porsche. What are you doing, you taking the bottles? Like, no, he was like, no, I'll repair them in a year. Started breaking some of them, and then, yeah, they just shipped them back. Oh, it's just, the whole thing has been.
Did he win the election?
No, he did not, he apparently all corruption over there, I believe.
Over there.
Yeah, Marshall Ward said, there were like 50 people running and you got 10 votes.
Well, I guess he's stuck fixing this for all.
He's driving a Porsche.
Does anybody use Troubleshooting? Listening? I mean, we do, because they're Miami.
I think the others are, I'm not positive.
Because other than just replace the springs occasionally, you have a pretty good level. But I know there's a price difference. Is that the reason why they haven't been over to you?
Those are about 800 a piece.
I think GOs are around $1,000 a piece.
Yeah, they're a flat 1,000 each.
You don't have to replace the misfits so much, as like little O-rings you have to replace a lot, or like the plastic liners like the non-pellet. So those are all like really cheap to replace.
They sell the kits too. Stuff we should have. There's a lot of history with the ODF bottles they use because of the most of the O ship and all that. So they use the Bollister style bottles. I was a researcher before my time. That there was a way to do the O-ring seal. So we do have a design that you can give to a shop. So we buy a mixture, we can buy parts from Ocean Test. And we have machine shops, make other parts. And I don't think they're necessarily cheaper, but they, and you can look at it tomorrow. We have the bottle shop there that will, every 36 place Rosette. And I know it won't fit on all Rosettes, and I know it's not something, but, we have those designs that like you build within a machine shop or something, that's their interest.
Will you share that? Would you share that? please?
Yeah, I can share, we've shared it before, we don't like, it's because of the labor to build them, we don't like, we have built them in the past for research, institutions stuff, but, like Noah wanted to buy some a while back, but they wanted to, that kind of, those kind of complications, but yeah, if everyone's interested.
Well, it sounds like you could charge a lot and they have to work, so.
Yeah, and they're.
Get a Porsche.
Yeah, of course, right.
Yeah, I shared it with Tyler, Brown, because you guys are three CTVs, I guess. And
Yeah.
you haven't done a huge amount of, you know, so, good work just checking out.
Yeah, exactly.
And it's like, wait all that time and get out there and do it.
as you were talking, I'm scrolling through your box trying to remember who supplied the bottles for the request that you have there, so maybe I think I remember.
I received a thing for this LCD.
It might have been, the Wondering Universe, I believe. Yes. Okay, great.
All right, I think Lee, you had an issue with thermometer and.
Yeah, let's go still, so she's on. Well, somebody was talking with, Matt Durham was talking about with Masako and RFR about the DGS preventers and grab ties, and it's kind of opened up, and so trying not to open up a complete can of worms, but like, what we've been working on for years is that the grab ties, either we have MSRs or it's, calibration engineering type data, but some of the requests with the DGS to share the calibration files has opened up some questions about, publishing that data, or having, is it an MSR? It's not, if you're doing a graph tie on land, is that a marine scientific book? Because it talks about being collected in the EC, but if you're taking these measurements on land, if you're publishing that data to, there's to the repository, the data that you collected without an MSR.
Yeah.
Without it, or is MSR we haven't gone to the state to ask these, we want it to be engineering data, but we just, it's caused some number of questions.
Yeah, because the big deal is it can't publish it.
Can't publish it, and countries have been sensitive about gravity data and magnetometer data because it is used for navigation weapon systems.
Yeah. Interesting.
That's why the BGM-3s were gun laying technology.
Yeah.
That was right, but the
Is there a
DGS
way around publishing?
still kind of working.
I mean, I think the idea is that it's valuable to have for groups like the EMPD and other scientists. If you want to use the data, it's important to have. So if we serve the data.
But can we embargo it? Because CFP is all based, like, even though like everybody has their own DG and whatever the acronym is for the new ones.
DGS.
Yes, sorry, DGM, DGS. Cause like, we just keep that data at the Cooley Data Library and have it embargoed. So it can't be, so it would be something that wouldn't automatically get back to send to our.
And then it's, we can embargo it R2R. We have data that hasn't been released. So we have that capability, but the question is. Why is it at R2R? If it doesn't eventually have a timeline for becoming public.
I think the problem though being like a major diplomatic issue with the State Department and then all of a sudden like potentially closing off the ability to do ties in foreign countries is reason enough to like, even without like the end goal figured out now of like ending embargo, I would say embargo it, because as soon as it's published, it's no longer engineering data.
So before with BGM-3s, we're entering that, we're doing the grab ties and putting it into the laptop and it's correcting the data, but that acquisition system doesn't exist in the same way for the DGS.
Right.
So that's where this request to put the grab tie data separately along with the grab data came up because we were just with the DGS as being new and figuring this out and sending it to, we were sending it to the PFP. And then we also did with, even with like easy stopping recording of easy, the DGS has a buffer, so we just enable recording it, it dumps everything that you collected and.
Oh, that's a problem.
Yeah, that's a problem. So there's a couple things, we're trying to work through some of those issues with the DGS. And we're trying to selectively ask questions about MSRs to not limit things. So if anyone has any ideas, we're continue to explore internal.
Yeah, have you talked to people in Moscow, you tried to see Polito?
No, I talked to Masako and then we've talked about it with my boss and our chief scheduler, just clearances and try to figure out, how to navigate this. I think I'm comfortable doing it, continue to do with MS, when we have MSR.
It's Neil, is that the name of the DGS guy? Is it, maybe it's for, you know, maybe months, talking directly to Neil about how to avoid that, he said, data pull down, data dump, limiting power.
Yeah.
And monitoring,
That's
that
something.
needs to not.
So, yeah, it's kind of others should be aware of it, yeah.
I know, I see you. Yeah, just for the record, don't send data card to heart if you can't make it. You don't know, right, what you have authorization to do, what's, you know, easy and so. So he could, you know.
And so all the data you collect, so for instance, school is going to be in Tahiti, and we're gonna transit to Punta Arenas, and in Tahiti, we're hoping to do a land counting, right? And you hypothetically need to collect that, and then we're gonna use that to collect the data all the way to, right? So that's all Tahitian data based on the graph that you did there?
It's the graph type data itself is a separate,
Oh, it's on the world.
yeah, so, yeah.
Well,
It's not corrected like the BGF3 data was, but you know, the graph type information is the PFP, not, says DGS.
we do some correction with it. Okay.
So he's saying that because it's collected in our forest soil. There's a community that you need to have permission.
Right, but then all the data after that is based on that.
No, but it's not only what.
Nobody can use that, nobody can use those specific numbers. They're built, they're buried inside of your time series.
Which is why it should be considered engineering data and not data data.
Right.
It's calibration data.
The State Department will be at the, I think Gabby, she's not a Fed, but she's gonna be there at the. You want us to, not like. Are you trying not to open it anymore?
I wanted to ask, make sure, I wanted to ask a very specific, I haven't figured out exactly the question to ask. Exactly, so trying to understand, I'm not completely up to speed on the DGS operator, so I was trying to get. First, I wanted to have the, sort of technical folks that have a conversation with our Moscow, try to get, I'm still collecting some information, exactly the sequence of things to ask your question to get a more favorable answer.
I would be very curious about the outcomes of this one. So definitely. What do you got somewhere? Share.
But I didn't want to ask the State Department without checking with idea. So that's something I can send out to the tech manager mailing list once I know information. It's something we've been debating internal in the past couple of weeks.
Yeah, so I'm continuing on, I don't know, Terry, Sarah, that's for me, Sarah. You touched on your SD profiling, sub-bottom profiler, do you wanna elaborate?
Yeah, I know it's not applicable to the small ships or if you have no plans of getting so there's the SVP 29, but then there's also the EMSVP, so if you have an E124, Kongsberg does have like a data package to manipulate your transducers to use it as a sub-bottom profiler. It's not the same, level as the 29. But it's good for folks who haven't gone through the process, like Scripps and that Thompson is now going through imminently. There is, there's some expertise within folks who are funded via various ONR offices and insist on visual, kind of more speculative, I would say, types of calibration methods. As opposed to max, extremely quantitative, easily repeatable, calibration methods. It's a continuous challenge because of personalities, really, more than anything, but it's something that I think as a community, we can do really well to help encourage folks to be, we really as a fleet need to only accept quantitative data for our calibration methods, just because it's repeatable and doing things visually. I have different cones in my eyeballs than you do, and I'm uncomfortable saying that we see the exact same color schemes on a piece of paper because I have no way of verifying it, right? Their end product is extremely good, really great imagery, but this singular person can't possibly be on every single sub-bottom cruise moving forward, right? There's an issue or things like that. And it's extremely time intensive. So we're just being aware of it, especially if you're, thinking about considering like the EM SVP that has yet to be like fully flushed out, I think, on the ship. I think that we was talking maybe comparing it on the Thompson, but it's mostly just an awareness thing, and I think that, again, as a community, if it starts coming up for your ships, let's all talk about it so we can have a unified voice, because some of these scientists are pretty powerful people with, serious backing at a federal level from, folks that don't typically fund stuff on our ships. So you want to dance delicately with it. So more just like an awareness comment. Yeah.
I'm gonna have, Concord, we're gonna have Concord on school week, and one of the things they're looking at is trying to do the EMSVP magic with our 304 and comparing it to our TOPAC. So I will put on Colleen to give me some quantification.
Very good, Matt, all about the quantitative, they're not the issue, but the folks who are the issue think that often more Kongsberg or Matt is doing is insufficient and garbage. And has been said, like, in fits of rage about, like, why, like, to the point where they have to struggle to understand that if your calibration needs to be so precise, you need to plan the time to calibrate every single time you go out, because you have significant amounts of hardware that gets beat up on a ship over the course of a year. Your calibrations need to be redone. And they were mad that the calibration wasn't still valid a year out. And so it's one of those things, kind of like that we saw with the heyday of multi-beams, and like, really the dream was that you set it and forget it, and the dream was that every time we leave the dock, we're pneumatic. And that's very much so what the dream is for the sub-bottom profilers, which are exponentially more complicated. So we still don't have those capabilities with multi-beams, no matter what system you're in. To have a stream for the profilers is exhausting. But I'm curious to see how it goes. Because we don't have on the Atlantis for a 29 on our gondola. And so that's kind of like our one option, but I can't even approach this program manager at the Navy to talk about it if it's not gonna be accepted by his group of scientists. Yeah. So. Oh. It takes a lot of energy. It takes a lot of cognitive and emotional energy to deal with this stuff. Yeah. So the most we can do together, the better.
We got a few minutes left. I think, since we're all together, and I don't wanna minimize this RVTEC, but we need to start thinking about next year, because there will be
an RVTEC
I
next
love
year?
your positive.
I'm the best at it. So we gotta start thinking of locations too, and you know, you guys are tech managers, we try to alternate hosts. So if anyone, you know, East Coast, Gulf Coast is interested, we kind of looking for a host.
Yeah, I know
Put it out there.
USM has been interested for years, but I think we've been kind of waiting until they go shift, so a few more years.
Yeah.
So
How
that's.
about Miami, Don?
We're supposed to do RVOC, but who we got RVTEC, so. We did it in 2015, obviously we can't do it all on our campus, if we did it at Marriott. I think is how we looked at it, and Bridget was, involved in that, Alice, obviously you were involved in it too. So just 168 people now, that's my own concern, man, 10 years ago, I don't think we were at 168.
Yeah.
Cause yeah, our auditorium is fine, but I prefer to have a desk to set up a laptop and do it, stuff, our auditorium before that, and but then, you know, breakout sessions, and that, I'd have to look into that. So,
Alright, well,
we do want to host it, keep in mind, November is hurricane season, doesn't end until November 30th, actually December 1st. And the way things go, I'm pretty sure there'll be another one popping up here shortly.
right,
There's nothing out there now, but, so keep that in mind, so travel could be. I got shutters on my house, but not everybody can come to my house.
Well, we better do it sooner rather than 10 or 15 years from now.
Yeah, well.
Or the six,
I was
hosting.
Yeah, hopefully in another 10, 15 years I'll retire.
What if we did it in like January? Rather than November, like that's a little bit longer than a year, but it might allow for some chaos.
Okay,
and
as long as
stuff.
you're talking 2027, not 26. But,
Yeah,
That's possible. I mean, I don't know how it works with everybody else traveling in, you know, that in the Northeast or, you know, you guys got snow and travel on, but there's not gonna be a perfect time anytime.
That's also a sugar period.
Yeah.
Before some.
That's true. I will be in the shipyard, yeah.
there.
What about Savannah? Did we ask Georgia? And it's also her, I mean, everyone on the East Coast is hurricane season.
Yeah, I mean, you guys are gonna get effects.
Yeah.
I mean, we could do any, we could also go out to June's institution, so for other institutions, I mean, held at Kangaroo, we held that. Not saying that, yeah, that's saying that, yeah, and a few other. Indian, yeah.
If you wanna extend it out, and assuming that we're still part of the greater community officially speaking. Indiana, won't see hurricane.
Or what about Duluth?
That was more recent.
Were we just there?
Yeah.
You got snow.
Oh, yeah, I thought that was RBS.
That was.
Yeah.
Yeah, pretty good.
I could chat to ASU and see if they want to host, but it's not. Even,
Well, we just.
it's not near the water,
That's warm in desert now.
yeah.
We did have a council.
Yeah.
Well, they had no-
That's not-
There's something out there.
No. Sorry, we had the annual meeting there one year, but yeah, I mean, they have a huge campus, I mean, I'm sure that they have loads of facilities too, so we'll put that on the list too, how about that? Yeah.
It's a good idea.
You sure we can do it in St. George's?
Well, hurricane season.
Put a marquee up outside the passing lane.
I know. We had it there, like my first year, it was 2009 or something like that.
Yeah, early 20, early 20.
Is that right? Yeah.
So, yeah.
That's one we heard of, yeah, and, yeah, but we've grown so much.
When it was last year.
It's the conference room.
Yeah.
Yeah, I remember I stayed on for the Friday to do ACP training, it was very popular.
Oh, yeah.
A lot of people wanted to stay in Revere for another day.
Yeah, true.
And the last time we did it here was just shy of 130. Okay, so now we're.
That was 10 years ago.
Was it 2016? I give it 2016. No, we said
No, we were supposed to go, we were driving in the Bahamas. I laughed, it's supposed to be 94,
Okay.
and everybody fit in the room with this. But I had my library map room, and I swear to God, this was sizable.
Yeah, yeah. Okay, well, we have a list and we'll see how Miami can work. And then going in tropical. Does anyone else have anything else to share?
I want to complain
Okay.
real quick. No, it's easy. We have parascientific meant for a meteorologic institution. And they're great, they work very well. But they're hilariously expensive. And what's even more horrible is they want $2,000 for cable. For cable. Wire with a plug on there. $2,000. Highway robbery. I mean, and I, it's terrible, but if you had the option to choose between parascientific and somebody else, maybe for a sample, I might encourage you to look more closely at the other option.
Proprietary.
It's a stupid little it's a RG45 or a R45 and power in one. So whatever that is.
That's supposed to be $8.5 grand for exact cable for the L75.
Oh, yeah, I believe that. Don't you buy RAM?
Yeah, that's got a couple.
Yeah.
Information.
I don't think they know.
Yeah.
Pictures and now they're $500 because they're using a different actual thread. So an off shelf won't work that more. So now 500 just for a simple connector. She could have made the threading.
Oh, I have a suggestion for folks, if you are doing, you're putting new juicers in, like, for say, an EK80. Even though, depending on where your conduits are, what other, key things, how you're running your cables. Most of us don't wanna introduce noise involuntarily, and so we go for the entire cable length directly to your juicer. Well, great, until your juicer fails, and you need to replace it, and you can't pull the cables because it's behind one of your big sonar arrays. And so we have an inoperable 38 kilohertz. We think it's in ceramics, we can't verify if it's the cable, we can't pull the cable. So we are looking to have Concert, provided I can get funding, come and make a wet plug bulb, and we're gonna have, so they're gonna just cut and reslice, so theoretically take out our juicers when we need to replace them. It will introduce noise, but hopefully by having Kongsberg do the engineering of it, they will then also own it. Like, we could do it ourselves, but then it's gonna be a finger pointing game. So if you are building ships, and their cable runs or something, if you can't isolate them, so you are able to actually access them when there's an issue or when something's at end life, and you need to replace it. We're considering doing. Yeah, and so we're gonna have like basically a pigtail from the juicer that then connects to the rest of the cable. And it won't, the data quality will have some, noise because of that. But right now, the alternative is that we just don't have that frequency working, period. And unless we take out all of the piecing for the, 124, which just got done, we can't.
You're talking about what they will plug instead of the junction loss.
Yeah. Yeah. So just a consideration, that's what we're dealing with, when you have an error or an issue with your ceramics, you can potentially deal with it.
That's something regarding if you're in shipyard or the build process, something that helped us tremendously on Schooliac was when we ripped up our old multi-beam, we had all of the conduits coated. We brought in like a company that does this for like industrial purposes, so all our conduits got coated with like a, I don't know, polymer of some kind. It protects it and it made the cable pulls like miles easier.
Definitely worth it. Atlantis, midnight, we found. Oh, there was a lot of, this does not, you cannot pull anything through this conduit anymore because the ship is old and it's just like a, like feral, rusty, congealed mess.
This is the right audience. I had a conversation with Tim, ongoing, but we're gonna remove our 710 out of the ship. There are parts of it that are not working, but we also have a brand new array and plenty of spare bits that I'm kind of trying to figure out what to do with. Anybody in here have 710?
We
Hey, buddy.
We have 712.
You're gonna buy it on that, aren't you? We don't have plans to be in Hawaii after shipyard that I know of, but maybe we'll leave a little package in your doorstep there, yeah.
Or at least see what boards are gonna be compatible with, you know, if you're getting involved.
No, we're getting it 2022. We're going really easy.
Well, worth checking, see if, because lots of us have 712s. At least.
Oh, 710 and 712.
Yeah.
Yeah.
And we do have spares if it does come up, we have a spare processing unit for 712 and the 124. That was something that we eventually got them. They sit in here in San Diego, so they can be shipped. So if the processing unit goes.
Separate, but related, your ADCP pool, what frequencies do you have?
The ADCP pool is no longer a funded activity.
You had a 150. What does that mean?
I don't know exactly how, but I know I don't have, I mean, I put in a minimal amount of salary. $30,000 a year to have someone be able to keep on top of the hardware and the coding and the getting the, when we would send out a cable, getting it back, getting it, and that, so I still have spares, but it would be, I would need some agreement that we're gonna get back to working. We were, that's what the 30K were, just to keep the inventory and keep things RMA, and cables and stuff, and all that, so we're no longer doing that. So I still have spares, but
But you're not on one.
we were doing the work of the RMA and getting it also, and then we're getting it coded with the clear signal and that type of stuff, so. That's what I want, in order to have I wanna end up, I would want confirmation that I'm gonna end up with an ADCP sitting on the shelf with a cable that's been clear signal coded, just like what we sent out. If we're not gonna do that, then someone's gonna do that, because I think that's that. In my mind, that proved to be the right model to keep these things available. So we haven't been, we haven't been keeping that inventory, which is. Unlike I think the short cable or something like that.
So Pelicans go in the shipyard this year, and we're completely refitting our whole ADCP, actually all our transducer are void in the machinery space, and I have those scripts.
We have 300, yeah, 300, yeah.
But we still send that back to you as normal.
Oh, it'd be great to get back to just have it on that, so just we have 300 on Sally Ride, we can, we've had to swap that out a few times.
My recollection is that the 300 they have is the same key. It was from the guy.
What's on there? I hadn't heard that.
We've got a new one waiting on the shelf, and then you take the strips one out to replace that.
Okay, yeah, I'll have to, if it's not worth it, I'll have to see how.
Well, I can look back at the records and verify that as soon as we put it in, it's not.
Question. Darren, we were preparing like inventories of all of our stuff. Is that gonna be available to the whole fleet? And will we include things like, hey, we've got a spare EM710 like in our warehouse? Just we'll know, oh, they've got a spare one on the shelf.
Can I answer that?
Yeah.
So those that were collected, that was not the plan. But we're happy to start taking that information, I guess eventually we'd love to get that sort of stuff in the MMP, that the government is united, the inventory is there, so that it's there. But the inventory that definitely has been, for most folks, for some folks, we've been doing more detail, but for most folks, the inventory we've been working on is more general. That is public, we plan to do public facing. So, you know, Joe scientists can say, who's got this group that. People in the bell, whatever. That was the thing. Yeah. But I guess it would be to get that information.
Or could we have like that type of information be like accessible only to like people in administrative positions for their MFP? So like I can see what Julian, what like UAF has as spares or what Lee has as spares that like, we don't necessarily need signs to know about these spares.
Yeah, exactly. That's what I'm saying. The other inverters, most of public funding, this would be something that they don't.
Yeah. That'd be helpful.
All right, this one is over.
Right.
So, we'll see y'all at dinner.
Yeah. Yeah. A little bit further.
A little bit further.
Thanks everyone for your patience.
Thank you online for
Stay
sticking with us.
Okay,
So.